Welcome to the next lesson of next generation firewall training. This lesson is dedicated to intrusion prevention. Intrusion prevention or intrusion detection is one of the core functionalities of next generation firewalls, and without it, these firewalls wouldn't be nearly effective as they are against cybersecurity threats. So, on the agenda, we are going to see about what we are going to talk today. The first thing is the overview section. In the overview section, we will define what the IPS-IDS is. We'll talk a little bit about the history of this feature or the network role, because the history is important in order to understand why the IPS functionality is built into our next generation firewalls today. We'll see also how it works and what the IDS can do for you. Of course, we will have a couple of demos. We will demo the configuration of the IPS-IDS feature on Cisco, Checkpoint, Palo, and P10. Okay, so let's dig into the intrusion prevention detection. Key role. What is the key role of IPS-IDS? Well, it's actually, as it's said here, catching of known vulnerability exploitation attempt. It works actually similarly as the application identification feature we talked previously about. As the application identification feature uses application signatures to detect known applications in a traffic, the IPS-IDS, on the other hand, uses an attack signature database in order to detect known attacks in a network traffic. And actually, the application identification steals the idea of detecting something in your traffic by using traffic patterns. The application identification steals that idea from an IPS-IDS because IPS is a much older functionality. Yeah, the IPS-IDS, well, it means intrusion prevention system and intrusion detection system. It depends on how you deploy it. You can deploy it in an intrusion detection way, so it can only detect attacks without being able to actually stop these attacks. And the prevention mode is when you have an intrusion prevention system mode, then it will actually automatically block these attacks for you. IPS is actually sometimes it's called virtual patching, because the IPS is especially useful when the new vulnerability shows up and there is an exploit. There is an already unknown exploit for this security vulnerability. So usually it's much quicker and easier to develop an IPS signature and to deploy it, and it's being, by the way, deployed automatically through daily IPS signature database updates. So then to implement a patch on a server, for example. So if you have a critical server and you need to patch it, it's not so easy process because you need to test the patch in the lab, and then you need to have some downtime of that critical server in order to apply the patch. Then there is a risk if that patch doesn't work or disturbs some other functionalities on the server. So it's much easier to initially have an IPS signature covers you for this new attack until you are ready to patch your server. This is why it's called sometimes the virtual patching. And the most important thing of when you are configuring the IPS, and you will see in our labs, it's generally extremely simple to configure the IPS, especially in a Checkpoint and Palo firewalls. But the key challenge here is not the configuration, but the optimal tuning, because IPS needs to be perfectly tuned, especially for your network and your network traffic. Otherwise, it has a potential to kill your production applications because it will detect some production traffic as an attack, which is actually a not attack. And if we are talking about intrusion prevention mode, it will block this traffic because it will think it's attack. So the key thing is to carefully tune the system. So when we are talking about the false alarms, the false positives, we have 4 types of events on IPS. Let's see what the event is first. The event on IPS is an, let's say, alarm when IPS detects something, and that alarm can have simple action of alert only, so it will not block anything. Then we are talking about IDS mode. And you can even set the IDS versus IPS modes for different signatures. So the single next generation firewall, for example, can be an IPS and IDS at the same time, depending on the signatures and the policies. But you will see that in the labs. So let's back to the event types. The event is, as I said, it's an alarm. An alarm can have an action of alert only, that will only alert, it will not block anything, or it can have an alert plus prevent action type, so it means that it will actually not only alert you, but it will automatically block the attack. And now we have false positives. False positives are when we detect attack, which is actually not an attack, but normal user traffic. And this is not something that we would like to see. But the worst thing, what can happen is a false negative. A false negative is actually a situation where we have a real attack, but it's missed by our IPS. It's gone undetected, which means that the attacker was successful, unfortunately. At least if as far as IPS is considered. True positive, this is the one we want to see. This is the true attack detected and hopefully prevented. So good job to everyone. It's a great action. So true positive is the purpose of the IPS IDS. And the true negative is also a great thing because then the legitimate traffic is not causing an IPS attack. So initial general best practice is when you are initially deploying an IPS in your network, first deploy it in IDS mode. So in order to filter out all the possible false positives. And now how to deal with these false positives? There are 2 ways. Quick way is hey, developer of the web application, I have my IPS is detecting some attacks when my users are using your application. But 99% of other web applications are worked fine. But I have alarms only for your application. Please fix your application. This approach works only in a land of unicorns, I will say. It works only on a PowerPoint if you want. Because if you approach like that to the developers, they will say, okay, but this is only problem with your IPS because I have other environments with no issues. Or they can say, okay, I can change the application, but it's an out of scope of the original project, so it's going to cost you some significant amount of money. And of course, your business will usually tell you, okay, change your IPS. So the most real, the approach in reality is to reduce the false positives, is to examine the traffic, talk with the developers, talk with the system engineers, talk with users to see what are the normal traffic patterns in those traffic that is causing false positives. So you need to learn about the applications on your network and how they work, how they interact with other components, other servers, with the clients on the network, how they interact with the internet, with everything. And then you will see what is really false positive and what is not. And then if you conclude, okay, this is really a false positive, so we can transit this false positive to transform it to a true negative. And good advice would be to have a signed approval of your security guys for transitioning the false positives to true negatives. So you can have a legal coverage if something happens, if real attack occurs, and the IPS detects that behaves as a false negative now because you changed something that was alarm to something that is not alarm. So that's why it's good to have a written approval from your security team. Okay. So the bottom line is when we are tuning the IPS, it's not a joke. It's really a task for an expert. It's not a novice task. It's not a task for a rookie, if you want. This is an expert. This is somebody who really knows your network, your organization, your users, your users' behavior, how your applications works, what to have from applications. what applications are deployed on your network, etc. So it's not an easy task, but the main goal is to reduce the false ones, the false positives and false negatives, and increase the true positives and true negatives. This is the result of the successful IPS tuning. Now we have, as we said, two deployment modes. The prevention mode, it's blocks attacks. Detection mode only detects attacks. Let's talk a little bit about history. As I said, the IPS is a much older box or solution than the firewall, than the next generation firewall. So traditionally, there were dedicated appliances because at that time the hardware was not up to its stakes. So hardware was not that powerful that it can bear with the stateful inspection firewall and at the same time with the application layer inspection through the IPS. So usually you had a traditional firewall deployed on your perimeter, and behind it, between your internal network and your traditional stateful firewall, you placed an IPS or IDS, and it will detect something that came through your firewall. So your firewall policy will allow some traffic. For example, it will allow traffic to the port 80 toward your web server from the internet, but then the IDS will try to detect if this traffic carries some known attack or vulnerability exploitation attack. Nowadays, the IPS evaluated into a core functionality of a next generation firewall. So nowadays, we do not need the dedicated boxes anymore. So you deploy the next generation firewalls. If you need a dedicated box for a next generation firewall, which I strongly advocate, by the way, if the budget can handle it, then we are talking about getting a next generation firewall, but using that box only for an IPS. It's entirely possible. So, but I think that there is no any vendor on the market currently that they are actually selling dedicated IDS IPS boxes. So they're all next generation firewalls, but you can use only an IDS IPS functionality of it. You do not have to use the entire firewalls if you do not want. Of course, there is an open source solutions such as Suricata and Snort, so you can deploy dedicated IPS system on your Linux machine, for example, and then you will have a real dedicated IDS. But yeah, now we're talking about next generation firewalls at the end, and the IPS is just a core functionality. Some topologies, well, you have basically two choices. You can either use the tap mode. This is on the left. So in tap mode, we actually have a traffic flowing normally, in this example, through a switch or a router. And this switch just uses a span switch port analysis functionality to just redirect a copy of the traffic to an IDS box. And this IDS IPS box will then detect attacks. This mode, tap-based topology, is usually incorrectly called the IDS mode, but it's not an IDS mode because although you are receiving as an IPS, although we are receiving only a copy of a traffic, we can block, even in this condition, we can block some TCP attacks, by example, with generating TCP reset packets in the name of a victim and an attacker. So virtually we are killing TCP connection that carries that attack. So it doesn't mean that if IDS IPS box is deployed in the span port mode or tap mode, it doesn't mean that it cannot block the attack. On the other hand, we have the inline topology when we are placing the IDS IPS inline in the network traffic, so actually traffic is flowing through it. And this is the most common topology nowadays because we are talking about next generation firewalls, and you will probably have a next generation firewall here in this box as long together with the IPS, so it needs to be deployed inline. But still, you can configure your IPS to work in the IDS mode, no matter if it's deployed inline. So it will not block anything, it will just detect things. And this is the recommended, by the way, as I said, it's a good practice to leave it in the IDS mode for, for a couple of weeks to just isolate the false positives. What are the advantages of the tap-based topology? Well, first thing is that this device is not an inline on the network traffic. There is no need for a redundancy unless you need, of course, constant non-stop IDS coverage. Because if this box dies, nothing will happen. Traffic will continue to flow, but you will, of course, not be able to detect anything. On the other hand, here, if this box dies, and unless it doesn't have a so-called hardware bypass, it will block your traffic. It will break your topology. So you need to have redundant systems. But again, if this is about next generation firewall, then definitely you will have a cluster of firewalls for redundancy. And yeah, this based mode on the left is not so heavy on perfect scaling of or perfect sizing of an IDS, because if your bandwidth increases or the throughput capacity of your IDS, nothing will happen actually with your traffic. So the latency caused by the IPS will not interfere with your production traffic. Of course, IDS CPU will be skyrocketing and it will drop packets. It will not be able to inspect traffic correctly, but it will not affect your production traffic. On the other hand, here on the right, if we are not scaled properly, if we're not done the sizing properly, then we can have an increased and significant latency caused by an IPS functionality. But again, since this is a next generation firewall, you should do the sizing correctly. Yeah, how it works, as I said previously, it works in the same way as an application detection. It uses signatures and it reads some traffic patterns from a payload of a packet, but it's not catching known applications, but it's catching known attacks. So these are some examples of attacks. It's a shell shock, heartbleed bug, SMB, eternal blue exploit, which is responsible for spreading a malware throughout your local network. And there are also some IP level and TCP and UDP level attacks, for example, on the IP level with some fragment manipulation, on the TCP with some TCP segments, overlap manipulations, etc. So there are some attacks on these lower levels of the OSI stack. Generally, for some attacks to be successfully detected, you do not need decryption on your firewall, but on some attacks you need a decryption, because if, for example, you're protecting some web server exposed to the internet which uses HTTPS communication, TLS protocol, then of course we need to decrypt traffic in order to IPS is able to examine the payload. Same thing as in application identification. The next video we will see how to configure the IPS on Cisco Firepower Threat Defense. Thank you for watching. Welcome to the video for demonstration of Cisco Firepower Threat Defense IPS configuration. In this video, we'll see how to configure the IPS policy and attach this policy to the access policy on a Cisco firewall. So let's go to the user interface. I have my Firepower Management Center here. I will log in. Okay, so the first step when configuring IPS solution on a Cisco firewall is to configure the IPS policy. This IPS part of the Cisco firewall is actually based on a Snort engine, and Snort is, as you may already know, the open source intrusion detection, intrusion prevention system, one of the, even if not one of, I think it's one of the most famous or the most known IPSs on the market. And Snort is used as a base to many other vendors, but here we are talking about Cisco, and Cisco is actually using not the Snort itself, it is a Snort engine, but their IPS part of the product is actually based on a SourceFire, and it's a result of Cisco's acquisition of a SourceFire a few years ago, and SourceFire is a commercial version of open source IDS. So yes, everything in all the terminology we are using here in the Cisco IPS configuration are actually Snort terminology. So let's first configure the intrusion policy. So we click on the intrusion policies. At the moment, there is no any intrusion policy, but we will create one. Yeah, I forgot to mention, I'm working this through the Firepower Management Center, as every other demo regarding Cisco that I'm going to show here, there will be based on Firepower Management Center. Okay, so let's create a new policy. So we can give it a name. So Internet IPS policy. Now I have an option, drop an inline. This is enabled by default, but I suggest if this is IPS deployed on traffic where there were no IPS before, I suggest to turn off this option. What this option means, this drop an inline means that the IPS will be working in the intrusion prevention, the IPS mode, which means it will actually block attacks if it detects them. If you leave this option unsigned, unchecked, then it will behave as an IDS, intrusion detection system, for a traffic covered by this particular intrusion policy. So let's turn it off. And when we apply it on the traffic, let's wait a few weeks. And then after a few weeks, we can see the results and we can see if there are any false positives. I'm sure there are going to be some false positives. And then, as I described earlier, we need to remove those false positives by carefully tuning the signatures and the rest of the IPS configuration. So let's not select drop an inline at the moment, and let's go to the base policy. A base policy is a template from which this policy will originate. There are several templates. Balance and security and connectivity is, according to its name, it's something balanced. So it will give you a reasonable set of signatures enabled, so to provide enough level of security, but it will not be too restrictive on some signatures that are taking care about, I don't know, protocol anomaly or something like that, because it will, let's say, it will give an equal opportunity for a connectivity and for a security. There will be actually only latest signatures. It will cover only latest attacks. I don't know, maybe a few years old. It will not cover anything. Another option is connectivity over security. This means that the security is now in the second plan. It's in the background. Its priority is the connectivity here, which means if you choose connectivity over security, we will have only few signatures enabled, and those signatures will be for the most critical attacks. But the rest of it will not be enabled, or will be enabled but will not be set with an action of drop, but only for an action of alert. And of course, we have the extreme situation. If we choose the maximum detection, then almost all signatures will be turned on. A lot of them will be actually blocking traffic. Of course, if we click the drop when inline, there will be coverage for even ancient attack, etc. For most organizations, it's the best way to start with balanced security and connectivity and see where it's going to take you. After we fill up all these mandatory fields, we can click on the create and edit policy. And so now the Firepower Management Center, or FMC, is now in the process of creating a policy. It will take a while. Okay, now it's loading the signatures of the base policy, which is in our case balanced connectivity and security. Okay, it's almost done. Okay, so now we have menu, we have the options which we will always have whenever we decide to edit this policy. So we can again turn off or turn on the drop an inline or the IPS mode. We can change the balance of security and connectivity. Signature updates are recent. It's only 1 day old, which is good. Okay, sorry, 2 day old, which is still good. An overview of our policy. This policy has an 8,938 enabled rules, but majority of these rules will drop actually and generate events. Only minority of rules, only smaller percentage of rules will generate only events. Of course, it depends if you are turned off drop an inline or not. So let's go see what we can do here. Okay, the rules. These are the signature of actually. The signatures are in Snort technology called Snort rules. Snort rule updates. SRU or Snort rule update is a version of Snort signature database, and Snort rules are called signatures, IPS signatures in a Snort terminology. So these are rules or signatures. They are organized by the categories or classifications. As we click the Microsoft vulnerabilities, we can click on some of them. Let's see the example. Here's the status of, it says it's rule state. If it's gray arrow, it means it's disabled. So this rule is not active at all. We can change it. We can say, okay, drop and generate event. With this option, the symbol of an action will change. So we see now an X symbol. X symbol means the signature, if it's triggered by traffic, it will generate events, but it will also drop the traffic. It will prevent the attack. Okay, if it's only generate events, we will see just an arrow, but it will not be gray. It will be clearly black or bold. Yeah. Okay. Usually at the start, you do not need to configure signatures at the beginning. Only if you see a problem, let's say the false positive, then you will see in the log which Snort ID rule triggered the alarm, the false positive alarm. And if you decided that this is not a risk for your organization, then you will simply either choose an action of alert only or disable this particular Snort rule entirely. So, as I said at the beginning, you do not need to touch anything. One thing you might experience is that if some users report that their applications are not working anymore, or there is a strange behavior in applications and you suspect that your Cisco IPS is blocking the traffic, even if you do not see anything in the IPS logs, it does not mean, unfortunately, that the IPS is not blocking the traffic. Why? Because we have something that is called preprocessors. Preprocessors are actually part of the network analysis policy, and I will show you that here. Network analysis policy. There is a default analysis policy, but we can configure our own. I will configure it just for test. It's balanced security and connectivity. It's usually a best practice to follow the same template, although there is no direct link between the IPS policy and network analysis policy. They are depending on each other. So if you choose as a base policy in the IPS policy, if you choose the balanced security or connectivity or whatever you choose, the best practice is to follow this choice during the creation of network analysis policy. If you do not create a network analysis policy, there is a default network analysis policy in place. And what the network analysis policy is for? It's an important part of a Snort, and it actually deals with normalizing traffic. What this means? Well, this means that we have different operating systems and different applications that are treating different layers of data or data transferred over different layers of OSI communication stack differently. Which means, for example, if we have HTTP server, for example, Linux, Apache, maybe some HTTP or URL or URI, Unified Resource Information Address encoding is different and various operating systems. So if the IPS wouldn't use, let's imagine that we do not have these preprocessors or the network analysis policy, then the IPS wouldn't know certainly if somebody is trying to bypass the IPS to escape the IPS detection by advertently changing the encoding. So by misplacing some characters in the URL, you can actually make that IPS not recognize the pattern it's looking for, the attack pattern it's looking for, but the destination server as a victim will recognize it. Because if the attacker knows that the victim is running the Apache server version in a particular version, then it can try to launch attack that the Apache server will recognize. So if we have some string that will trigger some buffer overflow security bug and try to exploit it, if we craft this URL or encode this request toward the server carefully enough, the IPS might be blind on it, because IPS might be based on different operating system and doesn't look on everything, on every character in a packet, every string in a packet, in a payload of a packet, necessarily the same as the victim of the attack. So that's why there are preprocessors, and they are doing a normalization. And normalization is actually a modification of this encoding or the content of the packet so that IPS is able to read it accordingly. So for example, if we take a look at the HTTP configuration, we can see here targets. These are some parameters, how the server, which method server should support, what to do with this type of encoding, actually, what to do with the compressed data, etc., what to do with ASCII encoding, and there is a tons of options. We do not have a time to go to this every option. For the Cisco IPS and the Snort in general, we could have dedicated course of a few hours at least in order to cover everything. But now we have a target option. So if we add a new server, and let's say we have a new server, specific IP address, okay, so I can configure these options for that particular server. So if I know the operating system, if I know these details, I can say, okay, this is, for example, I can say this is an Apache server. So the IPS, when it sees the HTTP traffic pointed to this particular IP address, it will know that this is the Apache server. So it will modify its encoding to be able to interpret the data that the potential attacker is sending to the server. It will interpret this data in the same way as the server or the victim will. So it will be more accurate. So even if you do not configure these preprocessors or normalization, your server will be protected. And this way we are making the Snort most accurate. And also, this contributes to a reduction of false positive alarms. So we can have this. I'm showing you an example for HTTP, but we can have it for TCP. We can have it for different protocols, for DNS, and etc. So, but what's the important here? If you configured something here and you are starting to experience some issues, connectivity issues in their applications, you might need to go in the IPS policy. Now I'm in the IPS policy and go to the processor section. These are category of processor rules. For example, I was here doing the HTTP normalization configuration part on the network analysis policy. So I should turn on the relevant or all the signatures handling the normalization, handling the preprocessors for HTTP. Obviously, there is a tons of signatures. I will not literally turn them all, but turn the signatures that make sense for your applications. Because the point is that the Snort preprocessors drops traffic if they are unable to normalize it, or if they see some anomaly in the protocol itself. It's not an attack; it's just an anomaly. So the network analysis policy and preprocessors, besides the optimization or normalization of a content, they're actually looking for anomalies in a protocol. So if they see an anomaly, they will drop the traffic. But if you do not have the signature or the Snort rule enabled in a policy, you will not see this in the log. So you need to enable particular processor signatures and set them the rule state generate event in order to get these alerts. And also keep in mind that whatever action you choose, you cannot prevent blocking of this traffic. So you cannot prevent blocking of traffic caused by preprocessors or network analysis policy. No matter which state is here, if you click disable, you will simply you will not see anything in the logs regarding this, but you will still have a drop traffic. Even if you say generate events, because for normal Snort rules, generate events means do not block, just alert me. It will still block traffic. So this is something that you need to be aware of. But for the beginning, and if you are not an experienced Snort user, I would suggest to not touch the network analysis policy. Only after a few weeks, when you filter the false positives caused by normal Snort rules, that is not by the preprocessors, then you can start playing with preprocessors to further tune your IPS and to further increase the security. Okay, next thing what we need to take care is firepower recommendation. Well, firepower recommendations are the IPS will monitor, will try to detect the operating systems and applications that are in use in your network. And it will, for a purpose of prioritizing the alerts or the events. Because if we have a server with an Microsoft IIS, or let's say we have a web server with a Linux Apache application, and if the IPS knows that on this IP address resides a host with Linux, with Apache on the specific version, so when it sees an attack for this server, it is trying to exploit the vulnerability known for Microsoft Windows, that is targeting a Microsoft Windows and Microsoft IIS web server, it will alert you. It can still alert you, but it will not give such a high priority to this event as if the case is that this attack was aimed against the Linux and Apache web server, and this host, the victim, is indeed the Apache, and in this case the IPS will give you a higher alert because the attacker obviously knows what it's doing. It's using the right tools for the right target. So, and the IPS will then look, okay, if the alert is action for the rule is the block, then okay, it will not care so much. It will alert you, but it will know that the attack is prevented because it's blocked. But if the rule says alert only, and the attack is aimed to the server which is indeed vulnerable, this means that this is the critical alert, and the IPS will mark this victim in the logs, in the reports, with the IOC indicator, which IOC is indication of compromise, which means that attack is successful because IPS only alerted, it's not dropped, and the attack was meant to the operating system and the application which is actually vulnerable to the attack. So attack probably succeeded, so you need to give a highest priority to this. Also, you can integrate the FMC, the Firepower Management Center, with the vulnerability scanners. And so then FMC will know what vulnerabilities your hosts you're trying to protect have, and it will accommodate alerts as well. So it can be a very smart and very secure system that's Cisco IPS, but it requires a lot of knowledge and a lot of tuning. It's not something that you will click and forget. Yeah, the Firepower recommend if we do not have an integration with the vulnerability scanner or with some asset management system or patching system, so the Firepower needs to learn the operating system and applications from a traffic. It will usually, for HTTP, it will inspect the user agent field. It will look on some options on the lower layers, on the transport layer, like initial sequence number, etc. It will try to fingerprint the operating system. It will try to find out which operating system is on these hosts, and you can help him by using the network discovery policy. Network discovery policy is actually telling FMC which subnets to watch and on which subnets it will try to discover the operating system and the applications on hosts by observing a traffic. So by default there is any network, but I recommend you to modify this, especially if this is a perimeter firewall, so because you do not want to discover the internet hosts, because it will discover literally every source and destination IP address for that it sees. So actually not a good idea, because this host database has a limited amount of space in a database, and you will quickly fill it up if you are actually discovering the internet hosts, and you should only discover hosts that you are aiming to protect. Really. It will also affect the performance. The most simplest, quickest thing that you can do is just, tell me, to discover only private IP addresses. So do not discover the public IP addresses. Hosts, you can use the hosts and applications I want to discover. Users, we will talk about this when we're going to talk about user ID functionality. Zones, you can say on which zones you want to discover, but some exclusions for ports, but I think this is enough for beginning. Just have private IP addresses in any zone. So now I can turn on the firepower recommendations. Also, be careful with this option. So what will happen if I turn on the generate and use recommendations? Okay, I do not have a traffic to use it, but maybe I can. No, the live environment do not have a real traffic. Okay, but what will happen if I click the general recommendation? It will actually generate recommendation. It will actually scan the host database, that is the hosts that it discovered using the discovery policy that we've seen before, and it will try to match the operating systems and applications with the snort rules in the policy. So it will. So the idea here is to enable only snort rules which are relevant for your environment. So if you do not have a Linux servers, it will not enable rules protecting the Linux servers, for example. So it will spare the hardware resources, spare the memory, etc. You can click this option as well. So accept recommendations to disable rules, which means that if the entries in the host database are not indefinite, so they have some time to live. So after the expiration timer, the hosts will disappear, or they will be simply overrun with the new hosts. And if a recommendation, you can schedule the recommendation to go, let's say, once per week automatically. And then it will, if it sees that there is no any Linux hosts anymore, but you had them previously, it will automatically disable the rules for a Linux host. Now, personally, if my IPS is not overloaded, I would not click this option, because this host discovery is not 100% accurate. So maybe some server team will install a new Linux server, and the IPS will not know it at the moment, and this server will not be protected for a while until it detects the traffic. So I will just click here and use the recommendations just to turn on the rules for operating system and applications that otherwise it might not have turned on, because but now if it knows that I have a host that these rules might affect, it will turn them on automatically. Okay, so that's basically it, and now I need to go and click to commit changes. This means that changes I made to this policy are committed and written to the database. And now after I deploy the configuration to my firewall, similar as we done last time when we were creating a access control policy for user ID, I need to deploy it to the firewall, and the policy will start enforcing its rules on my traffic. Okay, now I've created a policy, but says no access control policies uses this policy. I need to attach this policy to actually, let's call it real policy, that is the firewall policy. From the perspective of the administration or the user interface, this makes the solution a truly next generation firewall management solution, because it enables me to go into the access control policy. And now I have here my rules from the last time, and then I will go. Let's say I would like to apply this policy in this direction. Attach the IPS policy to the rule number 4, which means that this policy will apply on the traffic matching this rule number 4. This means that traffic from the internet is going towards my DMZ web server on the port HTTPS, and the application is HTTPS. So if I take this firewall rule to edit, I can go to the inspection and choose the intrusion policy. I have my policy, and now if I click save, and I click save once again to save entire rule set, and if I click deploy, now after the deployment is completed, the IPS will start protecting the traffic, matching the firewall rule number 4, because it has attached specific intrusion policy. Okay, it looks like we are done here, but not so fast. The Snort is comparing to other IPS solutions on other next generation firewalls is, I will say, complex solution, and you will see it. You will see how it's simple to do it in a checkpoint or on the Palo Alto networks. But here you have a tons of options to tweak. So far I've covered only like 30% of what you can tweak here or configure to improve your IPS. As I said, we will need an entire new course only dedicated for the Snort IPS to cover everything, but I'm just trying to cover in this short time everything what is critical to successfully implement the Cisco IPS. One another thing is so-called Snort variables. We can see them here. You have default variable sets. What this means, if I click it, I will be taken to the Object tab. Okay, so the Snort variables are actually describing where is our home network, that is our local network. For example, is a home variable, it says any, I can configure it, I can enter the address actually, I can browse the objects already defined. For example, I don't know, I think I do not have an object for a LAN. Okay, but I can enter it here, whatever, doesn't matter. So now this is the default set. Okay, now my IPS knows that my local network, this is the network that Snort rules are trying to protect, resides on this subnet only. And of course I can add, okay, I forgot I have network administrators. Okay, I want to protect them as well. External net is of course anything, but I can say external network is anything but home net. Okay, so everything which is not a home net is considered external network. Why is this important? Okay, this is important because if we take a look at the intrusion policy or intrusion signatures. Okay, I think I have a better place to view these signatures. Okay, this new version is removed. Okay, let's open our policy. I would like to show you where these variables are mandatory part of Snort rule definitions. So they are telling the Snort in which way to apply a protection, from inside to the outside or from outside to the inside, for example. But we also have another variables like DNS servers. By default, it's my entire home net, but I can specify the object for DNS servers. So I would say on these IP addresses are my DNS servers hosted, my HTTP, my web servers. For example, I can modify this, let's say not the home network, but my web server, DMZ web server. Okay. So now whenever the Snort rule says over traffic directed to the HTTP servers, the Snort will know that this is my web server and is on this particular IP address. So for rules that are covering web server attacks, these rules will only trigger and generate alerts if the attack is aimed against this web server. If the attack is aimed on some another host, and this attack is HTTP related, and this host is not defined under the HTTP servers, the Snort will not trigger an alert. So it will significantly reduce the amount of false positives. But if you are not sure that you have a complete list of your servers, it's the best to leave HTTP servers variable defined as a home net. So whatever a home net contains, it will contain the HTTP servers. The same is as we have with DNS servers and other servers. So that you are sure that every host in your network is protected. Let's see if my policies have a little bit mess here. So yes, it is. So let's see about rules. I will open any rule just to show you the direction. Okay, let's see. Okay, Microsoft vulnerabilities. I will choose anything. So if I click here, and I click show details, I see the rule configuration, the rule definition. This is the regular expression. This is actually a string. This rule is looking in the payload of a packet in order to detect this attack. And this is a position where it is. So it's relatively easy to write your own snort rules. And there is a rich snort community with a powerful rules you can update here. But please take a note of these $sign variables. These are snort variables. So you see, this rule will trigger only if the traffic is flowing from external network, and this is the external network, right? Definition of the external network snort variable, and towards the home net, and this is the home net. Okay. Only if the content of a traffic contains this particular condition that we are matching here. So if the same content goes from home network to the external network, for example, from your local network to the internet, the rule will not trigger. So you will not receive any event. So this will reduce the false positives significantly. So using snort variables can reduce the false positives. But also, please keep in mind that now you will not be able to see if some host is triggering, if your internal host is trying to attack some external servers, because the snort rules will not trigger the alert, because there is only for this particular rule, of course. For this particular rule actually covers only traffic from external network towards the home net variables. It's not covering traffic vice versa. Okay, and here I have a choice to use the default variable set I've just modified, or for the traffic matching this policy, I can apply another variable set. So I can have different variable sets for different locations in the network. So, for example, if I have the internet perimeter firewall, as if this is the case right now, I can set that home network are my all internal networks. I could say it's all private IP addresses, and external networks are all public IP addresses. And this is okay snort variable set for the internet communication. But if we have the IPS in the front of a data center, then my home net will be my server subnets, data center subnets, and external network will actually be my internal users, my clients, my internal network, because I'm trying with the IPS positioned in the front of a data center, I'm trying to protect data center servers from my clients, from internal network. So I have this powerful option called snort variables to tune this out. Okay, so that will be everything for this course regarding the Cisco IPS. The lot of this theory we will repeat in the in the PFSense part, because PFSense as a firewall is using Snort engine as well. So they are using almost the same terminology. So it's basically, if you know how to configure the Cisco IPS, you know how to configure you then understand the Snort configuration, and then you know how to apply the PFSense IPS configuration. But you will see this in the last video demonstration in our IPS lesson. So thank you for watching. In this video, we were going to demonstrate how to configure the IPS on a checkpoint using Smart Console in version R80.40. Okay, I'm here in front of my checkpoint Smart Management Console, and the place where I should go for configuration of the IPS is the obviously security policy and the threat prevention policy. Of course, before that, I need to be sure that the IPS blade is enabled on my security gateway. because IPS blade is feature or license that carries the IPS functionality. I go to security policy, threat prevention, and here I can define a protected scope. So the protected scope is actually a network or networks that I want to protect with this IPS. So I click here and I can protect my, for example, all the traffic that is coming to my internal zone, or even better, I can create a new network object for internal and say here define the subnets. Okay, I already have the object with this. I forgot the name. Okay, I have it. It's LAN. Okay, sorry. So I can simply drag and drop it here, or just click plus sign and select it with LAN. Okay, but I've just drag and drop. I've used the drag and drop method because it was more simpler for me. So there are specific rules, IPS rules. Checkpoint terminology, IPS signatures are called protections, IPS protections. I can enable specific protections for a specific site. I do not want to do that at the moment. I just want to have the most optimized configuration. So under the action, I'm choosing the profile. The place where we are configuring IPS and a checkpoint is called a threat prevention profile. It's similar as the IPS policy on the Cisco device, but on the Cisco device, we have dedicated policies for the anti-malware, for IPS, for URL filtering, etc. But in the checkpoint, everything is done through the everything, which means the IPS, the antivirus, anti-bot protection. Everything is done regarding to the threat prevention through the threat prevention profiles. So we have these profiles here. By default, we have the optimized profile, but we can easily clone. I'll just show you the optimized profile. I can clone it. I can optimize, but optimize 2 for IDS. Only because I want to have my IDS protections or signatures temporary to be set on alert only, because as we discussed previously, the best practice is if it's a newly deployed IPS, just leave the signatures on IDS mode temporary, just to see what kind of false positives you're going to find. So now let's wait until it clones. The console needs to clone the profile, and that'll show you the configuration. You already see here that this profile actually is taking care about IPS, blade, anti-bot, antivirus, threat emulation, and threat extraction. Now we're dealing currently with the IPS, but in the lesson where we are going to talk about anti-malware, we will explain all the rest of these aids on the checkpoint. And there is a performance impact on a checkpoint, so let's edit. So all the protections, regardless of which feature you want to use. So we have threat emulation, threat extraction, which are anti-malware, anti-bot, antivirus. All these blades are enjoying the same level of this overview configuration. Now we are specifically focused on IPS. We can turn off all these options except the IPS, but I will turn them on. It doesn't matter because at the end of this course we will use the rest of these blades. First option to choose is the performance impact. What kind of signatures you want to have active, or not only IPS signatures, but the protections in general. So medium or lower, because the IPS pairs, it brings significant load to the hardware of any manufacturer. So it's with the checkpoint. The same is with the checkpoint. So By default, this is an optimized profile. By default, you can set performance impact to medium or lower. This is a default option, and the optimized profile is best to be left for beginning with minor changes. I will show you what changes I will recommend to make anyway. So performance impact, leave it to medium or lower. So this means do not activate protections that are high on performance, so that they can put the firewall's operation in jeopardy because they will kill the CPU or memory. Severity of the attack. This means how severe the attack is, medium or above, perfectly fine. And the activation mode, so which IPS protections we want to be activated. High confidence. This means these protections are designed to or meant to be very accurate, which means that the risk of false positives is relatively low with them. So they suggest, checkpoint by default suggests that you prevent the attacks detected by the high confidence protections. Medium confidence as well. The low confidence, these are expected to bring a lot of false positives, just leave to detect. So using this profile, there is significantly less chance that you will break some production traffic with the IPS. That is, you will break production traffic with the IPS as a result of false positive alarms. Here, activate the security blades you want to have, and then go to the IPS options. So here we can specify additionally which IPS protections to activate. For example, we can set the product prevalence, for example, or CVS score, file types. For example, for Office file types, I want to have specifically activated protections. Product prevalence means activate common signatures, common protections for the most prevalent products used in networks nowadays. So specific type of vulnerabilities and etc. So you can choose which kind of protections to activate additionally, but if you do not choose anything, this means activate all protections that satisfy these conditions here. And I think it's the best way to do it. Again, which protections to deactivate? These are default settings, and they are for most of the organizations. It's best to leave this intact. So leave it just so. It's a threat prevalence is obsolete, so some rare or obsolete attacks are not needed to be covered anymore, and that's why we can spare some hardware resources. Updates. I'll show you where to configure the updates, but what to do with the newly downloaded protections or signatures. We can set them deactivate and activate. This is by default. We can leave them inactive, or we can set them in the staging mode. So this means that they will be in the IDS or detect only mode for some time period. I think it's like 30 days or something like that. I'm not sure what are the exact values, but it can be found in the checkpoints official documentation as well. But you can see the signatures in the staging mode, and then you can either manually or automatically prevent to the prevention mode. But this is useful if you have some sensitive environment that needs to be protected by the IPS, but it's not tolerant for communication loss, some mission critical applications, etc., and you do not want that some new signatures inadvertently block traffic, because new signatures can cause false positive very easily because they are new signatures. So we do not know how they will behave yet on the protection traffic. So we can leave them or detect. And here you can configure to exclude protections. For example, leave all new signatures to detect except those that have a critical severity. So if there is some new critical attack that is already known to successfully attack and endanger a lot of environments worldwide. For example, some new ransomware. So, for example, the Eternal Blue Microsoft vulnerability on the SMB version 1 protocol, which is responsible for a spread out of or outbreak of malware and ransomware infections such as WannaCry throughout local networks. So maybe if this is signed as a critical event, maybe you want to immediately be able to automatically block these attacks as soon as the new IPS signatures arrives on your firewall. So that's why we can figure this. This is about the update. That's pretty much it. Okay, I cannot obviously change the optimized profile. That's why I made this clone. I can say edit. I would just say just turn on the detection mode for the beginning. Detect everything. Do not block. Please do not block anything here until I'm sure that there is no false positives. And also, I will configure the staging. Just activate me immediately some protections that are pinged from critical attacks. Okay, new critical attacks. Okay, so now I have my threat prevention profile set for the IPS usage. Just need to wait a little bit until the profile is updated. And then we can apply this profile to our threat prevention policy. I just choose my new profile here. So now everything, protected scope means traffic that is originating from my local area network or traffic that is going towards my local network. It will be covered with configuration with the protections enabled here. Okay, so this is the threat prevention profile. This is the main thing when you're configuring anything related to threats on the checkpoint. But also please be aware that there are 3 different categories of protection or inspection settings on a checkpoint firewall. First one is the IPS protections. If I go to the IPS protections, I see all these IPS protections. These IPS protections from Threat Cloud are actually protections that you get. These are IPS signatures that you get through the regular updates, but you need to have an IPS blade license for these in order to get these protections. Okay, so there's a lot of these protections, obviously, and also we have something that is called core protection. Sorry, I clicked not critical. I just wanted to on the core. Core protections, there are only 39 of them currently, and these protections are coming together with the update of the checkpoint operating system. They are built into an operating system, and they do not require, they are IPS protections, but they do not require the IPS license for the IPS blade. They do not require the IPS blade, so they work on every checkpoint firewall. Okay, and the third thing that might block your traffic are inspection settings. Inspection settings are actually something similar as a network analysis policy that we've seen at Cisco example. It cares about anomalies of the protocol on the protocol level. So these are not particular attacks, but some anomalies. For example, invalid retransmissions or retransmissions with invalid sequence numbers on TCP, invalid checksum, out of sequence TCP packets, etc. So you can configure what to do with these inspections, what to do when the checkpoint firewall detects some of these events. So they can be inactive, they can be dropped, but this is the default inspection profile, so I cannot change it, but I can create my own profile. For example, I can use my own profile. Okay, and now I can set what happens with the I will select show profiles, and I will select my profile. My profile I've just created, and default inspection profiles to see the differences. And now I can actually set something that, for example, I'm expecting TCP out of sequence traffic because of some issues in my network. So I can simply tell in my profile, I can simply switch this to override with action accept. So please do not drop my TCP out of sequence packets. And now I need to apply this profile to my firewall. So now currently it has default inspection profile, which blocks almost everything. Now I can see, okay, I can apply my inspection profile. This is the inspection settings profile. Also, I can choose what I can tell. Here is the place where I can tell the IPS what to do with the core, what profile to use for IPS core protections. Remember, these are protections that are not related to the IPS blade specifically. And I can choose the same profile I created for the regular IPS. It's optimized IDS only because I want to use the same settings basically. Because usually you do not care if this is about the core protection that is protecting you or some protection that is came from Checkpoint's threat cloud and that you pay the license for. You only care to if they are able to protect you or not. So now if I want to have my checkpoint firewall to not block anything regarding to the deep packet inspection, to the IPS, and etc., and the protocol anomalies, then I will simply use my optimized IDS only profile, which is actually not blocking anything, but detecting anything. And I will apply it for the core protections as well. I've implemented it in the threat prevention policy for the rest of the protections, the licensed protections. And also I would like to have inspection settings profile that do not block the TCP out of sequence traffic and similar things. So now I have it applied. And the great thing with the checkpoint is that you will be able to see everything in the logs. So, and you have a single log in the smart event. If you're using the smart event blade, you will have a single correlated log with the events from both the firewall, from antivirus blade, from the IPS blade, from everything. So you can easily search to these logs and see the logs in a single place, in a common place. So it enables you to very quickly troubleshoot the false positive issues. Yeah, so Optimize is implemented. So now I need to publish these changes so that so now, because remember they are currently only in my console. And after that, I should push the policy on the firewall in order to start enforcing its configuration on my traffic. The only one thing I didn't mention here, because it's a little bit out of scope for this course, is going to the details, but you can, both in a Cisco and in a checkpoint, you can configure what to do when your system is overloaded, what to do when the system is under a certain load. So you can configure on both of these vendors, you can configure the checkpoint to bypass, or Cisco to start bypassing some inspections after, for example, the CPU load is over 70% and similar, similar thresholds. So it can be useful if you care about connectivity, and everybody cares about connectivity. So you do not want that your security tools actually act as a denial of service for your network. So it's a great thing that you can optimize this. Okay, so this is everything about checkpoint IPS for this course. So stay tuned for the next lesson, and thank you for your attention. Welcome to the lab demo of Palo Alto Networks regarding the intrusion prevention configuration. So let's go to the web user interface for my Palo firewall. I will log in as an administrator. So in order to configure the policies, is by the way, the very similar configuration as we've seen at the Cisco example, but with only difference that you do not have to configure the preprocessors. You don't have to care about you cannot configure preprocessors and normalizations of in such a great amount of details with Palo as you can with Firepower or actually the Snort. Okay, so first thing is you need to figure the IPS policy, which is called actually a vulnerability protection profile in a Palo Alto language. So there is a vulnerability protection. There are already predefined two of them. One is the default and one is the strict. This one strict actually it prevents aggressive actions to some signatures, some IPS events, while the other default is actually relying on action default. Action default means that whatever action is defined at the signature definition, this action will be applied automatically. It will be transferred automatically to the profile. Usually my best practice is to configure my own vulnerability protection profile. Usually make a clone of a default one and give it a name. So now the most basic configuration is here. All what you need to do is just to see what you want for attacks with the different severities. You have critical, high, and medium, and it depends of if it's a client originated or server originated, which is the target. Usually it depends on which is the client and which is the target. Threat name any, CV marking any, host type depends. These client critical are, for example, aimed to protect a client from a servers, and these are doing the opposite. They are protecting servers from a client. And there is an action, which is a default. As I said, default action reads the configuration from the signature. For example, the way to see the IPS signatures on the Palo Alto firewall is to go to, in the vulnerability protection profile, go to the exceptions and click show all signatures. Now you see all possible signatures on this system. They are calling the signatures threats. So in the Palo Alto language, IPS signatures are called simply threats. So here you can see this default action which is applied to the signature, and of course you can make an exception. That's why that's this tab exceptions. You can make an exception. For example, you can say for this particular thread, I would like to change an action to drop, for example. Let's go back to the rules. Here I usually what I do, I configure my own action to I want to be clearly seen. I want the actions to be clearly seen when I'm looking at the profile configuration. So any critical and high attacks, I just want to have an action of drop. Let's comment what those actions means. Well, default, as I said, it reads the configuration from the thread definition already pre-built. Thread definition comes through the IPS signature update. Allow action, of course, means allow traffic, even if it's attack detected, and even do not generate a log. Alert action means allow and generate a log. A drop means silent drop. The firewall will simply drop the packet without notifying either the attacker or the victim. Reset client means sends TCP reset if it's a TCP connection about. Of course, send TCP reset to the client side of the client party of a TCP session that carries an attack. Reset server is doing the opposite, just sending TCP reset to the server side, reset both. And the block IP, which means block entire communication from a client IP address that triggered the alert. So difference between drop and block means that drop will only drop specific attack attempts that are actually fits under the simple client critical category. This is what the drop does. But that client that tried to attack our network will still be able to generate another traffic to our network to initiate new sessions toward our network and even to maybe try new attacks. But if we say block IP, then this means that if I can say, let's say duration for 1 hour, so block the client address. For example, client, usually I want to block client, not a server. Block a client address, block any communication attempts from the client IP address for the next 1 hour. If the client triggered an IPS event, it means that which is a critical one, it means that it tried something really severe against my network, and I want him banned from my network for an hour. I don't want to be him to or her to be able to initiate any kind of traffic with my network. But be careful with this. I usually use a drop. I do not use this block because only for exceptions, of course, because this means if there is a false positive, you will block entire communication with this IP address. And this can be easily some important server that your users needs to access to, such as internet banking or something like that. And then you will actually block the entire communication with this server for next 1 hour or whatever period you set here. So I will say use the action drop. It's a silent drop. Of course, you can use the reset client server or both, but this means the firewall will send the TCP reset packets spoofing the client or server IP addresses, which is fine. On the other hand, because the attacker, if it's an automated attack, which is mostly the case, at least at the early stages of some attack campaigns against your organizations, early stage attacks are usually automated, generated by bots or similar scripts. So if the program is attacking you, if you reset the connection, probably the client, that means the attacker, will give up automatically because of their operating system. Their TCP stack will give up from the connection. If it sees the TCP reset, it will immediately turn the connection down. But on the other hand, you are actually putting hardware resources of your firewall in jeopardy because your firewall needs to spend extra resources to generate some packets. And this could cause a denial of service condition on your firewall. So please be careful with what you are doing with this option. I prefer that my firewall silently drops the traffic, because I will see if something's dropped, I will see it in the firewall logs, so it will help me to troubleshoot the issue. But I don't like when my firewall needs to send any kind of packets to offender, because, as I said, it can create a DOS condition on my firewall. So I said the drop here. I configure here this one as well. So it's a high, and use the server critical, also say drop, and the server high, I'm also using an action of drop. So critical and high attacks I want to be dropped, silently dropped by my firewall. Okay, so I can clearly see now. You see, I've changed the actions for those critical and high attacks, so I can clearly see what the action will be executed upon them by just looking vulnerability protection page here. Now, when I've created my IPS profile, then I'm going to my security policy, my firewall rules, and for example, I want to implement this profile on my 2 rules. One is my 3 rules. Let's say I want to implement to my users when they are going to visit the internet. I just go to the actions in the profile setting, and I can choose the profiles. I can set all the threat prevention profiles here. But for now, let's focus on the vulnerability protection, which is the Palos name for an IPS. So I think this is my IPS profile. I can also use groups. For example, if I have several profiles like antivirus, anti-spyware, or URL filtering, vulnerability protection, etc., I have multiple profiles. I want to combine all these profiles into a single group. Now I can create a new group profile. So I can have different profiles. You see, you can have this, I can have that kind of combination of security profiles that are placed into a simple group. So on whichever rule I want to install these protections, I just simply choose a group, my profile group, instead of clicking on each of them and filling up each of them for each of my rules, because I can have 50 rules. So if I want to edit them all for a protection regarding of profile protection settings, I will need to click on everything. But for their visibility and to be clear to you, right now I will use the specific profiles and I will use only my IPS profile. When I click OK, now I have applied my IPS profile to my rule. Okay, I can see it here. It's applied. Okay. I will do the same with the other rules. So I just go to the action, the profile, vulnerability protection, IPS profile, set OK. The third rule. Okay, so now all my 3 custom firewall rules have an IPS profile applied, and after I commit the configuration changes to the firewall, my firewall will start enforcing an IPS rules or the signatures on my production traffic. I have these 2 default rules. For example, interzone default is a default rule, but it's an action of deny, so there is no purpose of setting IPS profile for a deny traffic, because the firewall will first match all these columns of a packet against the firewall rules. And it finds a match. It's a top-down first match approach, which means whichever rule matches the packet first, or whichever rule matches a TCP or UDP session first, this rule will be enforced against this traffic. So when all these columns from zone, from source, destination, application, service, URL category are matched, action is applied accordingly. If the action is OWL, only then these threat prevention profiles will be applied on the traffic as well. So there is no point in applying profiles in a rule that has a deny action. Actually, I cannot even do that because the action is deny. I think so. Yeah, the action. If I put the action deny, yeah, I can see it still apply the profiles. Yeah, but there is no any sense to do it. So because the traffic will be denied before the threat prevention features such as IPS starts examining traffic. So I do not need these. Okay, so my commit is completed. So now my IPS works. It started to work, and now protecting my traffic. So this is all what you need to do in order to configure an IPS for an Palo Alto firewall. And this is everything you can do actually. So it's very simple, as you can see, but it's according to my experience and from my customers, and also from some independent lab testings, it's very, very effective actually. Although simple, but effective. Okay, so thank you for watching this video about Palo Alto and IPS configuration, and I hope you enjoyed this video, and thank you for watching. The next video will be about configuring an IPS on a PF solution. Welcome to the last video in our IPS part of next generation firewall training, and this video is devoted to pfSense. So we're going to talk about pfSense as an open source firewall platform and how to implement the intrusion prevention on this platform. There are two options for now. You can use either the Snort engine or you can use the Suricata IPS. I will show you the Snort engine, but the Suricata is very similar in the configuration, and it really depends on what you prefer. Some guys in the pfSense community are strongly advocating the Suricata, and we are seeing the Suricata presence to grow over time over the Snort. But the Snort is still the most popular IPS, and you can share the Snort signatures between the Checkpoint, the Cisco, and the pfSense, and other Snort-based solutions. So that's why I'll give a plus to the Snort. Also, the Suricata is using the Snort signatures as well. So it depends on the detection engine and reliability and how it's heavy on your hardware. These are some differences. Okay, so let's see what we can do with the pfSense in a way of IPS. So I will log in to the management interface of my pfSense firewall. Okay, in order to use the IPS, you need to first check that you have on the package manager that you have on Snort or Suricata, whatever you like, as a service, as a package installed. Here I have the installed. If it's not, just click on the available packages and find the Snort or Suricata and just click install. It's that easy. Yes, when we were doing in the last lesson about application ID, we were talking, if you remember, about the pfSense application identification potential. And then we told that actually the pfSense is using a Snort signatures to this open up ID from Snort to detect the applications, which is true, I think, for us, even at Cisco, but you cannot use the application identification in the firewall policies directly, but everything is configured through the Snort here on the pfSense. That's why during this demo, we will show the application identification configuration as well, because it's just a few more clicks on the IPS than regular IPS configuration. So after we confirm that we have installed Snort as a package on our pfSense firewall, now let's go to the configuration. Configuration is then on the Services tab and just click on the Snort. First, there are some global settings. Of course, here you enable the Snort rules, updates, SRUs, so you want automatic updates. It's free of charge. I mean, there are commercial updates provided by Cisco or Cisco Talos, their threat intelligence center, or you can use the community signatures. It's automatic and it's free, as I said, except those commercial grade signatures or rules that you need to pay a license to a Cisco. You here hide your Snort user account by using this Snort OINC master code. This is like an API string API identification for so your Snort instance is able to pull the updates from your Snort account from the internet, from the Snort website, so Snort community website. And here we need to enable Open Up ID if we would like to use the application detection as well. So check this if you want to use the application identification. And from here are settings. Here we can check the update status of the Snort rules, that is the Snort signatures. We can see the logs, the alerts. There is no any alerts currently. Blocked hosts, so I will explain that a little bit later. Pass list is a kind of whitelist, so that you can define what happens with the some IP addresses, so that the IP addresses in this pass list will be allowed and they will never be blocked by Snort. Suppression is you need to define some suppression rules to, for example, temporarily suppress alerts if there is a snort rule that is generating a lot of alerts in a short time period, such due to some kind of port scanning, etc. So you can define the suppression rules. So let's say, okay, give me an alert, but not on every packet that triggers the signature, but give me alert every 1 hour or something like that. These are kind of suppression. Okay. IP lists, these are lists for the compromised IP addresses. So these are kind of blacklist provided by the community and by the regular updates. You can use your own lists if you want. So these are kind of blacklists available on the internet. So if Snort sees the IP address that your network is communicating with an IP address from this IP reputation list, it can block this traffic entirely from this IP address. In order to use the Snort, we need to enable it on the particular interface. So, for example, I have two interfaces here on my firewall, WAN and LAN, so I can enable it on a WAN, and I will do the same on the LAN. So if I enable it on a WAN, Snort will monitor traffic that is coming through my WAN interface, that is ingress to my WAN interface, wide area network interface. But if I enable it on the LAN, which I will do later, then Snort will inspect packets also coming in to my LAN interface. That means traffic that is going out of my networks to the internet. This is all that we need now for an interface. Yeah, here, important feature, if we leave it so, like this, without any further changes, the Snort will not block anything. It will just detect potential attacks. If we click here block offenders, and if we leave it in the so-called legacy mode, it means that every Snort alert, every host that is causing a Snort alert will be blocked. So, and we'll be able to see these hosts on the blocked list. And we can, of course, clear the host from the block list. We can define how long to keep hosts in the block list, but they will be blocked. So this is actually a configuration for an legacy mode, and the legacy mode means that Snort will actually get only a copy of packets and then decide what to do with them, and then inform the pfSense firewall engine to actually block this traffic. On the other hand, inline mode is similar as the mode that can be found on the commercial products, such as Checkpoint, Cisco, or FortiGate. Which means that the Snort engine is installed. By the way, I'm not sure if Apollo is using a Snort engine. I don't think so. And the Checkpoint as well. Although the Checkpoint can load the Snort signatures, Snort rules. But for example, the Cisco Firepower Threat Defense, they have the Snort engine positioned between the actually network driver and the kernel of the operating system. So all packets are actually flowing through the Snort engine. So then the Snort is able to immediately block the traffic. And in the inline mode, we can set individual signatures, whether to block or alert for our traffic. So this means that we do not have, because if we use the legacy mode, then, for example, if we see source IP address to block, in legacy mode, every line that will cause the Snort alert will be blocked. On the other hand, on the inline mode, we can configure whether the Snort will block the traffic or not on a signature level, or the Snort rule level. Let's put it in the inline mode, although on the community there is a lot of rumors that there is a lot of complaints on the inline mode. It really works with a certain type of network interface drivers, so it can have some quirky behavior. So use inline mode with your hardware with a caution. That means expect problems. Okay, so, but I will use the inline mode because there is a lot more options to show you in the inline mode. Okay, I'll save this configuration. So, and I need to turn on the Snort. I need to start Snort on this particular interface. And I can on the same configuration on the LAN interface. So I do not have to click everything from the beginning for another interface. My LAN is still in inline mode. Is the inline mode as the same as my LAN interface. So now let's see what we can configure else now when we have the interfaces. Now see what we can configure. For example, on these interfaces, we have the categories. We need to enable signature categories. We can select all simply. Please note these open up ID rules. These are rules for the applications, for the application identification. And these are rules for attacks. I can either use, these are not rules, I'm sorry, these are categories only. I can either select these certain categories or I can use the policy. This is the similar as we saw on the firepower on the Cisco side. So it's IPS policy, so I can say whether I want to balance it. This is Cisco is calling this balanced connectivity and security, or maximum security, or connectivity over security in the Cisco language. So since Cisco is using the snort, the terminology is virtually the same. They have the same meaning. So I'll use the balance. In this, snort will automatically enable certain rules and set actions for the rules. I can choose to set all alert action for all my rules, or let the policy, this balanced policy, decide which rules will have alert action and which rules will have a drop or blocking action. Okay, now I need to click the save. Please note that I cannot choose the WAN categories anymore. I cannot click on them while I have selected the IPS policy. Only if I do not have policy, uncheck the IPS policy, then I'm free to choose the categories. But if I'm using the policy, policy will take care about it. So it's very simple, actually. And now if I'm looking to WAN rules, I have WAN rules. We see these snort variables. Please snort variables. Remember these from the Cisco demonstration. Of course, you can configure them here. You can have different set of variables for your pfSense firewall interface. For example, if I have WAN and LAN interfaces, I can set the different values in variables for a WAN interfaces versus the LAN interface. So these snort variables are the same as on a Cisco because they are snort variables. They are not pfSense and they are not Cisco variables, snort variables. Processors, these are like network analysis policy on the Cisco side. Similar, very similar. So it's used for normalization of a traffic so that the IPS can see the traffic through the same eyes as the potential victim of an attack. So it has better accuracy of detection of an attack. And also the preprocessors are responsible for modifying or normalizing traffic or removing some anomalies from the traffic or blocking traffic that has some anomalies like TCP out of sequence numbers or some HTTP anomalies. So everything that is not according to the RFC standards for a particular protocol can be blocked, basically. Okay, so when I go to the WAN rules, I see my rules and I see my signatures. Let me see my rules and an action for a rule. So I can actually, these are categories. For example, exploit rules. And you see there is a state of block. It's not a drop. I'm sorry. It's a disabled. This means that the rule is disabled. But I can click here and choose the action. I can enable the rule, and then I can choose the action as well. So I can drop the silent drop, reject is send the TCP resets to the client or server, and alert just generate the alert. And default, just leave it to the policy or by the rule author. But rule author selected, the default action will reach that selection. Okay, please note that since I have configured on the interface settings, since I have configured the inline mode, then I'm able to actually choose actions for my rules on a rule basis, on a rule by rule basis. So for each individual rule, I can choose an action. In case that I'm not using the inline mode but the legacy mode, then it will block every IP address that is causing an alert. Now when I go to the, I need to save it first. Now when I go to the my rules, now you can see that I cannot change the rule action anymore because there is only available action is an alert action, but whichever host will cause the alert action, it will be found itself on the blocked list. Now I promised you last time that will show you the application ID on the PFSense. Yeah, it's very snort and snort related. So actually, I'll show you this on the LAN interface because it's still in inline. It's easier to use it in inline, or because in the legacy mode it will block every host that uses any application. This is not what we want to do. So just choose the LAN categories. I need to make sure I will select all OpenIPID rules. I will select them all, simplest and quickest now. So what I can do with the application ID, I cannot, if we compare PFSense solution with the commercial products such as Checkpoint, Cisco, and Palo, I cannot here actually bound the application ID functionality to my firewall rules, which means I cannot say traffic from this IP address to this IP address is allowed only for a YouTube application. I cannot do that. I can only rely on the snort variables in the applications. For example, I will now, sorry, I didn't select it, I didn't save the configuration. I need to save it in order to put it on force. Now the snort engine needs to restart to accommodate the new configuration, to load the new configuration. When the snort engine is restarted, there can be some outage of the network. The same is for the firepower threat defense, but on the Cisco side. But on the Cisco, you can configure what will happen with the existing connection. So you can, and the default action is, I think that the existing connections will survive, but only new connections will be blocked while the snort is reloading. I think on PFSense, the snort reload means that you will lose traffic, you will lose temporary communications through the box, but it's very quick. It takes under a second to reload, but it depends on the load on your hardware, current load on your hardware. Okay, so now when I go to LAN rules, I should be able to do the open up ID rules. For example, social networking rules. Okay, so now I have social networking rules. And I can choose what the action will be. So, for example, MySpace. Do I want to allow MySpace from my organization to the internet? I can say no, just drop it. Okay, so now I'm effectively dropping MySpace communication with the internet. That's all what I can do about it. I cannot configure as I can do with Palo, Cisco, or Checkpoint. I cannot say, okay, but marketing users can use MySpace, or users originating from marketing subnet can use MySpace, but users from the sales department cannot use MySpace. I do not have that granularity in rules. And I'm just relying on the snort variable. So I cannot change. I can just see how the signature works, what is matching, but I cannot change the variables and etc. So let's say it's very primitive and simple, but hey, okay, it's a community edition. It's a free product. It's developed by community. It's developed by people who are actually willing to provide some good piece of software to the community, and they do not intend to make money directly from it. I mean, you can pay the support for the official support, but the product is not the commercial grade product, so that's why it's lacking some features. So we do not need to do some hair splitting here, just to looking at every tiny detail. We cannot compare it with the commercial solutions. It's a great solution if you have some budget constraints and if you need a quick firewall, effective and easy to set up firewall, IPS, the web proxy, load balancer even. For $0 for no cost, you just need to pay the hardware, and the hardware can be built by yourself, or you can purchase the hardware, but you can run it on every kind of Intel PC if you want. So it's actually very simple to set up with very good community, and it's something that will work at least as a temporary solution until you are able to purchase commercial grade product. Okay, so this is all for PF Sense regarding the IPS. So let's wrap it up. So at the end, let's draw up some conclusions here about the IPS. The IPS, or intrusion prevention system, or intrusion detection system, relies heavily on signatures to accurately detect attacks. So it's important to be regularly updated, and on most platforms, as you've seen, these updates are performed automatically. So there is no need for an administrator intervention. There are two modes of operation, the IDS and IPS. IDS only detects attacks and IPS prevents attacks. So the best practices for, as I will not say smaller, but simpler organizations or networks to start with the IDS mode, and after you weed out all the false positives, then just prevent it to the intrusion prevention system. This is if your environment tolerates sometimes some connectivity failures in the case that some new signatures introduce the false positive. If you have a very connectivity sensitive environment, such as some SCADA centers or some operation centers or emergency centers, then of course the recommendation is to leave it into the IDS mode. But keep in mind that when you have the IDS in the detection only mode, then it's effective only as the eyes looking at it. So you need actually a security operations center, so SOC, to constantly monitor for the alerts and manually escalate some potential incidents. Otherwise, it will be used only as a forensic tool, so you will be able eventually to see what happened, what caused the attack, which was successful. Yeah, also keep in mind when you're talking about IDS versus IPS mode that automatic blocking is most effective against modern threats. Because, for example, if we take the WannaCry ransomware, so it takes minutes that one infected computer starts scanning other computers, finding vulnerable versions of Windows, unpatched versions of Windows, and try to exploit them. So these exploit attempts could be prevented by the IPS easily, but if you have an IDS, they will be only detected. So in a matter of minutes, if you have no other means of preventing these attacks, in a matter of minutes, your entire network can be infected with that ransomware. And that brings us to the third point. The bottom line is the IPS IDS requires very careful tuning to be effective. So this means that you need someone who knows your environment well and to know the capability of the IPS systems that you are deploying. And the best is that it has a lot of experience, especially in your type of business, financial, oil and gas, and similar. So thank you for watching this ITS IPS lesson, and stay tuned for our next lesson, which is about URL filtering topics. Goodbye. Welcome to the fifth lesson of our next generation firewall training series, and it's dedicated about URL filtering. The agenda for this lesson is, as in the previous lesson, to see what URL filtering is through an overview section, and then see the lab demo on different next generation firewall platforms. Okay, what is the URL filtering? URL filtering is actually the capability of a firewall to filter the web access request based on the URL field in the request. So it has a similar effect on the traffic or on the security as the application filtering, but comparing it to application filtering, URL filtering does not filter on the entire content of a payload of a session. It only filters on the URL portion of the request. So it's not so powerful such as an application filtering, because For example, the URL filtering only covers the web traffic, while the application filtering covers almost any kind of applications, and the URL filtering in most cases can be bypassed just by entering the IP address instead of the fully qualified domain name in the URL itself. So in some cases, the firewall will not be able to match the URL request against the list of categories it has. So, for example, here in the picture we have 3 categories: adult only, gambling, and malicious. But the modern firewalls have dozens of these categories. So you set up the policy. We will see that in the demo videos. You set up the URL filtering policy on your firewall, and then basically you can control what kind of web category content your users are allowed to access. So that's pretty much of it in an overview. So let's see in the next lesson how to configure this URL filtering on the Cisco Firepower. In this video, I'm going to show you how to configure the URL filtering using the Checkpoint Smart Console on the version R80.40. So let's go into my Checkpoint Smart Console. Okay, before you are able to use the URL filtering, you need to enable the blade, the URL filtering blade, and you need to do so on 2 places in the console. First, on the security gateway itself, just click the Activate Blades and make sure you have the URL filtering blade selected. And in the security policy itself, you need to enable the URL filtering in the access policy, in the access control layer. So make sure you have this checkbox turned on. And after that, you are ready to set up your first URL filtering policy in a checkpoint. Please keep in mind that in the Checkpoint firewall, you do not need to set up different policies for URL filtering, the application filtering, or the port filtering. It's everything contained in the services and application column. So, for example, if you click the plus here on your security policy rule, you will actually have all possible ports, the applications, the URL filtering categories, everything is here. If you want to be specific on the URL filtering category, you can go to the category section and you can see the all categories. But also keep in mind that these are not only the categories for URL, but also the categories for the application blades. For example, if we click the education, you see that the relevant blades are application control and URL filtering. That means that the checkpoint will apply the relevant blades, provide you the best security for your filtering, for your access. So actually, you as an administrator, you do not need to care about which blades your firewall will use to accommodate your filtering policy, to accommodate your policy. You just need to select the content you want to filter, and the firewall will do the rest. It will take care to provide you most secure way of doing it. So if I add I can add the education and I can add the entertainment as well. On the entertainment, also we are using the application and URL filtering blades. And now we have the action. Action can be an accept, which is understandable by itself. Drop can be interactive. If your clients are using web browsers, they will be redirected to the web page, telling them that this access is not according to the corporate policy, so that they know why their connection doesn't work. Also, we can ask the customer to accept the company policy. So, for example, we can warn them, okay, I'll let you access this particular application or URL category, but you need to click that you agree with the company policy. And after that, you will be allowed to access. And inform actions, the access notification or access approvals is just notification that for example, the access notification will inform the end user that they are accessing something. which you can describe. This can be against or not against the corporate policy, but the end users will be informed that they are accessing the content which is not in line with the company policy. For access approval, so they say, okay, we approved your access to this content, so please be aware what you are doing. And for example, in the if we have the ask action, it's going to be if the customer responds. This is a kind of interactive access. The customer needs to, as I said, the customer needs to select that they agree with the company policy and continue with access. So all these actions will be recorded in the firewall log. So you will know that the customer X, the end user X, accepted the risk and willingly accessed the content which may not be safe enough. Okay, and that's it. The logging, of course. And after we are set up the policy, we need to publish the changes from the console to the security management server database. And at the end, just simply install the policy in order to push the policy from the security management server to the security gateway, that is, to the firewall. And that's it. The next video, we're going to show you how to do the same thing on the Palo Alto networks. Hello and welcome to our new video. This is a video about configuring URL filtering on the Cisco Firepower Threat Defense platform. So basically, when we log into the Firepower Management Center, then we should go into our access control policy. And when we enter the access control policy, then we choose the access control rule on which we would like to apply our URL filtering. For example, the most common kind of rules is rules governing the access from the local network to the internet. So basically, if I create this rule, I just go to the URLs tab, then choose the kind of, I just choose the URL categories, or I can choose the reputations of them, just add them to the rule. You notice that there is currently we have any reputation. I would like to control the access to these URL categories no matter what reputation they have. But of course, I can choose like, I don't know, like the education content, okay, but only if the reputation is trusted, okay. So this rule will not cover the educational content if the reputation is lower than the trusted. So if it's a favorable, neutral, questionable, or even untrusted, this URL will not be fetched by this rule, even if it fits into the educational category. Okay, so just put the save. Okay, and this will by default allow the access to these URL categories. Okay, but maybe if I do not want to allow access to these categories, then I can choose a different action. I can choose the block action. It will be just a silent drop of the connection. Or I can choose the interactive block, for example. In this case, the access will be blocked, but the end user which access is being blocked is going to be redirected to the web page hosted on the firewall, which will tell him that his or her access is not according to the corporate internet access policy, and etc. So in this web page can be also fully customizable. So we can customize the appearance and the content of that web page. Okay, so this is the URL filtering which we can use with the access control rules. So we can be very specific what we can allow or not in terms of zones, source destination, networks, applications, ports, etc. But also the Firepower Management Center allows you to control access by the URLs in the Security Intelligence tab. So these are the URL categories containing URLs that are known to be malicious. So for example, select usually select all of them and just put them to the blacklist. So every kind of access to these URLs that fits into these malicious categories is going to be blocked. Okay. And of course, the save. And of course, don't forget to deploy your new firewall policy in order to have an effect on the traffic. So in order to push the policy on the firewall itself. Okay, so that's it. And in the next video, we're going to see how it to configure on a different platform. Welcome to the video demonstration for the Palo Alto Networks firewall in regards to URL filtering. Let's go to the firewall user interface. Go straight to the security policy and choose your security policy on which you want to apply URL filtering. URL filtering can be applied in a security policy in two places. One is the simplest place, just to use it here, just under the servers, the URL category tab, just select the URLs you want to detect. Then with the action, choose what to do with these. Use allow, you can drop, or you can deny traffic. Difference between drop and deny is just deny will just send an ICMP unreachable message or TCP ICMP unreachable message back to the initiator of the connection, and drop will silently drop. Okay. Or you can use the allow action and specify some under the profile, specify your URL filtering profile. So you can create the URL filtering profile. And by the way, this is the more powerful way to filter URLs because you have a lot more options to do. So this is actually a recommended way from myself personally. For example, we can specify the categories, different categories like games and gambling. And for example, we can do what to do with these URL filtering categories. So I can choose the allow. Allow means it will allow the access without recording a thing into the log. So nothing will be logged in the firewall. Alert action, on the other hand, will allow the access too, but it will log the access into the firewall log. Block will silently drop the traffic, and the continue interesting because it will face the end user with the web page. The end user will be redirected to the web page in which there is a text. You can customize it by yourself, and you can warn the user that they are accessing content that might not be as safe or it's against the corporate policy. But they are allowed to access by clicking to the continue. By clicking to the continue, the end user agrees that it understands the risks. So this continue click is also logged into the firewall log. So you have documented the fact that the customer has been warned, and despite this warning, he deliberately choose to access the content anyway. The other thing is, for example, we can allow, for example, the financial services category. Again, just here the block, be more realistic, And here on the financial services, I will allow them. But since my firewall is tightly integrated with the user account database, such as the Active Directory, it will know if one of my users will try to submit the corporate credentials, such as username and the password, to the website in the financial services category. So I will block the attempts of user credential submissions to these sites, but normal browsing to the financial services category website will be allowed. From the other things, what I can do here under the URL filtering profile is just you can, for example, choose what log. It might be useful to log the X forwarded for field if your end users are behind the proxy, for example, so that you can reveal the real user IP address. User credential detection, I've already explained it. Here we can choose how to do this, actually. Insert something into the HTTP header, or use the machine learning to detect the phishing detection or malicious JavaScript behavior. And of course, I need to give the name to the profile. I can apply the profile here. I apply the vulnerability protection, that is the IPS profile. So I will not choose, any here, but the action is allowed. If traffic matching the source, destination, application, or port is allowed, then I will apply these profiles, and among them is my URL filtering. The same profile I can apply to the multiple roles, which will save me a time. I do not have to configure the URL filtering for the multiple roles. And that's it. So I can put OK, and just at the end, don't forget to commit changes to the firewalls, so you can start actually filtering traffic. So that's it about the Palo Altos and URL filtering. And in the next video, we're going to show you what we can do with the URL filtering on the pfSense open source platform. Right, in this video, we're going to show you how to configure URL filtering on the pfSense platform. Okay, let's log to the pfSense. This is the main page of the pfSense firewall. And as I already said in the IPS and application filtering lessons, this pfSense is not really a next generation firewall itself, but it can provide next generation firewall functions, although in a limited way by relying on third-party products. So for the URL filtering, we need to use a Squid. Squid is an open source proxy platform. In order to do so, we need to set up the pfSense to be used as a proxy. It can be a transparent proxy, which means the client needs to enter the proxy settings in their web browsers, or it can be a transparent, which means clients do not have to do anything in their configuration. But configuring pfSense as a proxy server is beyond the scope of this course. Unfortunately, we do not have time for it. But the first thing, you need to go to the package manager just to see if you have the Squid proxy and the Squid and Squid Guard installed. Squid Guard is actually a filtering part of the Squid, so we need both of them installed. And configure the policy. Policy is configured under the services. We just go to the Squid Guard proxy filter and just go to the ACL, group ACL. We have already configured this rule test. I will show you. I can specify the client, source IP address, time. I do not have time defined, but I can specify if this rule or policy applies weekly or in specific days in a week, etc. And the target rule list I can set up here, and I can select certain URL filtering categories and decide if they're going to be allowed or denied or whitelisted. The difference between allow and deny and whitelist is, of course, deny will block access. Allow will allow the access, but only if it's not restricted by some other rules. So if we have a conflicting rules, one rule claiming that the same traffic should be allowed and the another rule same traffic should be denied, the more restricting ones wins, so it means the traffic will be denied. But if we set the whitelist option, then the whitelist has the most weight, I will say. So whitelist means that the traffic will be allowed. For example, this hobby cooking website URL category, if it's whitelisted, then access to this website category is going to be allowed no matter what other policy says. And that's pretty much it of the pfSense. So at the end, we have to wrap it up, all the things about URL filtering, and go to the next lesson. At the end, let's wrap it up about all these things and what we said about URL filtering. Some key pointers here. Okay, the first of all, URL filtering controls access according to the URL categories, which means it's a security measure, of course, but it's also a productivity measure on which you can apply on your firewalls to increase your employment's productivity. If we compare the URL filtering with the application filtering, the URL filtering deals only with the URL part of the access request, while the application identification actually monitors entire payload of the packets or the session in order to detect the application. So that's why the URL filtering is only applicable to the web traffic, basically, or on some solutions, maybe on the FTP as well. But the application control filtering, of course, it's applicable on any kind of applications, literally. So that's it. And in the next lesson, we're going to deal with the antivirus features or anti-malware features on next generation firewalls. So thank you for your time and goodbye. Hi, welcome to the next lesson. This next lesson is dedicated to anti-malware functionality on next generation firewalls, of course. We'll see how the next generation firewalls detect malware, and in the lab demo portion we will see how to configure it on the different platforms. So how next generation firewalls detect malwares? Well, there's two ways. One is normal by using the signatures. So the firewall analyzes the payload of a traffic and is searching for known signature, known hash of a known infection. So when we have a known file, such as, I don't know, the Microsoft Word.exe or other known file which is infected with the particular virus or malware, this infection produces the particular fingerprint or the hash. So when the firewall sees that hash in a payload of a traffic, it detects it as a malware and then takes actions depending on what you configured it to do so. The other more powerful way is, because the problem with the detection by the signatures is that the infection must be already known to the firewall vendor. So the firewall must be supplied with the latest signatures and the attack needs to be known. But the problem is with so-called zero-day attacks, when we do not know the malware yet because it's a new variant or even the completely new virus, then the detection by signatures will certainly miss that malware. But the other powerful weapon in our arsenal for the malware detection is the so-called sandboxing. So sandboxing is basically sending a file to the cloud environment, so-called sandbox environment, and in that environment the file will be executed as if it's executed by the end user, and it's going to be executed on the different operating systems like Windows, Mac OS, etc. So it will be so-called detonated to see what it's going to do, if it's really a malware or it's some benign file that cannot do any harm. So if the file experiences malicious behavior, then the report is sent back to the firewall, and the firewall admin, of course, will see how that file behaves. But the more important, the firewall will in future block that hash without any further analysis, because after the analysis is done in the sandbox environment, the hash is recorded, and then if that file with that virus is seen again in our network traffic, it will be blocked immediately. And of course, there is a lot of next generation firewall vendors are also have their endpoint protection products, which are tightly integrated with their firewall and especially tightly integrated with their sandboxing feature, which means that if the end user, for example, uses the USB stick or get the infected file bypassing a firewall because it was downloaded through the home internet connection when the user was not connected to the organization, the file will be still sent to the sandbox environment because the endpoint protection, the agent installed on the endpoint on the user workstation is also equipped with the same sandboxing feature. So the file will be still sent to the sandbox environment, usually in the vendor's cloud, and executed there. So if endpoint agent will be notified immediately, or this analysis takes like a few minutes to be done, and after the analysis the endpoint will be informed if the file is malicious or not. So if the file is malicious, the endpoint agent will prevent the file from executing. And also the firewall, your firewall, if it's from the same vendor as the endpoint agent, the firewall will be notified as well. This hash, this file is infected with this particular virus, as produces this hash, and if that hash is seen in the network traffic, the file will be blocked. So any additional user who tries to download that file from the internet, the file will be blocked immediately without need for an additional analysis because the endpoint agent already done so. And it is the same in the other direction. If the firewall sees that file first, before any endpoint agents, the firewall will do the analysis in the sandboxing environment and in the vendor's cloud, of course, and then it will inform the endpoint agent that particular hash, if it's seen, is known to be a malicious file. So if any endpoint in your organization tries to execute a file, it will be still logged as malware and treated as such. And here we have some examples of how this sandbox report looks like. So this is taken from Palo Alto Networks firewall, but it looks similar on the other platforms. We see that this particular file, creates the following child processes. It creates the following file. It creates or modifies the following Windows registry keys. And of course, we do not see this in this example, but it's not fit on my screen. But at the end, that file is being reported as malicious and then treated as such, of course. So in the next video, we will see how to configure the anti-malware and sandboxing on the Cisco Firepower. Yeah, and the one important notice, I didn't mention that before, sorry. So sandboxing environment can be in the vendor's cloud, which is the cheapest option. Usually you need to pay some license, but it's the cheapest and simplest option. Or you can purchase the on-site sandbox appliance, which will be installed on your premises. It's a more expensive solution. Of course, the sandbox appliance must be from the same vendor as the firewall and as the endpoint if you want to have some integrated solution. But what this local sandbox appliance will give you is the privacy. So if your organization is under some policy which does not allow sending files to the third-party cloud, then the local sandbox appliance will be your ticket to a successful anti-malware battle, because then you do not have to send any files outside of your organization. So the local sandbox appliance will learn from the cloud how the malware behaves, and it will learn how to test if the file is truly malicious. But no any file will ever leave your organization. So now let's go to the Cisco Firepower threat defense demo. Okay, let's see how to configure the Cisco Firepower threat defense for anti-malware defense. I'm going to my Firepower Management Center, and then you should go to the policies and click the malware and file. And here we create a new file policy. Let's say it's called my anti-malware policy. And now we can add a rule. So, for example, we have a rule. First, we can choose the application protocol on which we would like to detect files. It's not only for malware, it can be used for any action. For example, if I want to block executable files from being downloaded or uploaded from my organization, I can create a dedicated rule for this. So the protocol on which the firewall is able to inspect or detect files, I can choose any. detect the actions, detect files will just log any kind of file you choose here. I mean, for example, let's say executables. So I can here choose the particular type of executable, or I can select the entire category. And then I can choose the direction of transfer where I'm going to detect the files. Let's say it's any, and then choose the action. Action can be detect files. Detect files means my firewall will log any executable file it sees in the traffic. Or block files, my firewall will block files type executable. So it will not do any malware analysis here. So it will just block file if it's an executable. So I can save that rule. Okay, so I will block any download or upload of the executable. And I create now additional rule for fighting the malware. So again, the any application protocol, but then I can choose the malware cloud lookup, which means I will do some anti-malware analysis. So I can choose, I will later choose which files I would like to apply these measures, but the Spiro analysis is just a local analysis using special engine in the firewall. Dynamic analysis is the sandbox. It's uploading a file into the vendor's cloud or onto the local sandbox appliance. The capacity handling will take care about if I have too much files stored on my disk in my firewall, then some files will be put in the queue for analysis. And the local malware analysis will be done by the local anti-malware engine, which is fed or trained, which is using some kind of artificial intelligence, and it's fed regularly through the updates for new malware techniques. Generally, the vendors, both the endpoint vendors or firewall vendors, they generally are using more and more, they're relying on the artificial intelligence to detect malware. So because there is a tens of thousands of known malware today circulating on the internet, and there is no use of being able to detect each of these malwares. Because on the other side, when we have 10,000 malwares, known malwares, for example, we have like 15 or not even more or less, like 15 ways how the malware infects the PC or how the malware do some damage. So instead of focusing on detecting the every malware accurately, all 10,000 malwares, which takes a huge database, takes a huge hardware resources, why not focusing on detecting the malware techniques? Because there are significantly fewer malware techniques than the malwares out there. So the vendors now are using artificial intelligence more and more to actually learn the protection systems such as firewalls or endpoint protection. So the protection product will know how the malware behaves. So we do not care which malware it is anymore, but we just care about if the file or the URL, doesn't matter, behaves maliciously or not. If it behaves maliciously, it should be prevented. So the local malware analysis is actually locally analyzing the files, but dynamic analysis is the most powerful one. It actually analyzes files in the sandbox environment. But not all files are capable of or eligible for dynamic analysis. So there is a specific category, dynamic analysis capable, and the firewall will be able to dynamically analyze only these types of files. So if I want to do some dynamic analysis, I will select these files. And if I would like to store files, I would like to store the malware files so that I can see, so maybe because I want to download them carefully, of course, and do some analysis later by some third-party tools for forensic purposes and similar. Let's store unknown files with the unknown verdicts for which the system is not certain if they are malicious or not. And we store the files in the custom store. Here we will see all files which were dynamically analyzed, and from the custom store we can see the download. We can click on to see the sandbox environment analysis results. Okay, so I will take some actions for dynamic analysis. And of course, I forgot to click the local malware analysis, of course, category, because I selected the local malware analysis. So these are my two rules. Okay. Of course, I need to modify it because you see, I have the executable files. I got a warning that the executable files will not be analyzed because I've already blocked the executable files. But I'm fine with this because I will analyze the Microsoft Office files. I don't care. I don't want my employees to download any executable files, so I'm okay with that. And the advanced tab, I can set up additional settings. For example, to do the first time analysis. What this means, if the file is seen first time or its hash is seen the first time by the firewall, not by the only particular firewall, because this is the Firepower Management Center, by any firewall managed by this Firepower Management Center. So if the file is seen first time, then this file will be, while we are waiting for the verdict from the cloud, from the Sandbox cloud, we will do the local analysis just for short, just to be quicker, just to get the more information. So the local analysis will not be thorough like dynamic analysis, but still it can reveal some malicious behavior in the file. So if we detect it sooner, it's better. The custom detection list, okay, this is what I'm explaining here. If I choose to store files on the custom detection list, then I will be able to use that list to see the files and to see the malware sandbox report for these files. So the clean list is just for the files which are clean. So if I would like to download them, I don't want to because all this takes storage space on my firewall. What to do when the cloud disposition is unknown? We will use the local malware analysis and similar methods for analysis, and the file will be assigned some score, threat score, depending on its characteristics. So I can select, for example, any file where the cloud disposition is unknown will be marked as with a threat score of high. So I can be able to see that in the logs to bring my attention. What to do with the file inspection? Do I want to inspect archives? Yes, and how deep I can go for inspecting archives. What to do with the archives which are for some kind of reason unopenable, so the firewall cannot open the archive? I will block them, and I will also block the encrypted archives because I don't want to. If I cannot see it, I want to prevent my users see it also. Then I click save. So I've saved my file policy. And then I need to apply that policy to the access control policy in order to apply these file and anti-malware measures against my traffic. So I can click my firewall policy and choose a rule which covers traffic on which I want to apply anti-malware policy. And I go to the inspection and choose the file policy. And here is my policy. I reference to my policy here and click save. And of course, I need to save it in general. So now we see on my rule enter internet, I see that there is file policy being applied when the save is completed. And of course, we need to deploy changes. Don't forget to deploy changes to push this policy to the firewall. Yeah, okay. So that's it. Thank you for listening or watching, and see you in the next lesson. Now let's see how to configure Checkpoint Smart Console for anti-malware protection. So, okay, first thing first, we need to check if we have the particular blades activated on our security gateway. First thing, we need to have the antivirus. Antivirus blade is used for detecting known malware using signatures or known hashes. Threat emulation is a checkpoint's name for the sandbox analysis. It can be done again in the cloud or locally on the dedicated threat emulation appliances. And the threat extraction is an interesting feature preventing zero-day infections or patient zero infections. So Because the sandboxing, as we see in the Cisco and as we will see in the Palo Alto, these sandboxing are actually analyzing files, but first file with that particular hash, which is unknown, so that's why and it's sent to the sandbox for the analysis, is let through. So the first user who is downloading a malicious file can be actually infected with the virus because the analysis in the cloud has not been done yet. Remember, it needs a few minutes to do so. So in these few minutes, the first user, or so-called patient zero, can be infected. Of course, if you have the endpoint protection products, this file execution of the file will be prevented by the local analysis and the machine learning analysis analyzing the behavior of the executed file. But if you do not have such a smart endpoint protection, the first end user, so-called patient zero, can be infected indeed. So the threat extraction is actually preventing this by it's enabling true zero day, as the checkpoint claims. So the threat extraction actually extracts or removes the potentially malicious content, such as the macro scripts from the Microsoft Office files, etc. Or you can set it to convert the file to the PDF and sent to the end user. And the end user will be able to use link provided in an email. The end user will be able to use a link to get to the known file, to get to the original file. So this way we are effectively preventing these patient zero situations, because the end users initially, while the analysis in the cloud by the threat emulation is not done yet, these users will not be able to get the original file, which can be potentially malicious, and we do not that yet because the threat emulation is still in progress for the file. But they will get a cleaned version of the file, safe version of the file, or a sanitized version of the file that can be used for, for some viewing the content or getting an idea what a file about is until the threat emulation is done. If the file is not malicious, the end user will be able to use a link which the firewall automatically inserts into the email if it's about SMTP traffic, or click on the redirected web page if it's on web traffic to get the original file. Because we now know, after the threat emulation or cloud sandbox analysis, that the original file is safe for the end user. Okay, so once we have these blades activated, we need to go to our security policy and check if our security policy has a threat prevention layer enabled. It needs to be enabled. It is. And then we go to the threat prevention part of the policy and go to the profiles. Profiles are placed when you configure everything related to the threat prevention on the checkpoint firewall. So it's an IPS, it's anti-malware, everything. So I've already pre-created the threat prevention profile, and I can edit it, just show you the settings. So here I have the Sandblast is the checkpoint's name for the malware analysis in the sandbox, and it contains of threat emulation, which is actually emulating a file in the cloud. It's a typical sandbox emulation. And the threat extraction is what I've already mentioned. It's the extracting a malicious content from the file and delivering that file to the end user until the threat emulation is done and until the threat emulation results reveals that the file is not malicious. If the file is malicious, of course, the end user will get only this cleaned, sanitized version of original file. It will not get an access to an original file. And we need to activate the certain threat prevention blade for antivirus. And now we have an option to set up these features. First, antivirus configure to inspect files, to detect malware files from which interfaces. By default, these are external and DMZ designated interfaces, but you can select it, of course, to inspect all files going through your firewall, on which protocols you want to apply the antivirus detection, and process which kind of files. You can enable the deep inspection scanning, which means it's using special machine learning techniques for local analysis. And you can also specify specific files, for the inspection. So would you like to drop specific files, or would you like to inspect those files? Okay, I will set the most optimized option to process file types known to contain malware, such as executables or the Microsoft Office files. Archive scanning, I want to scan archives. Of course, if the archive is too large, I can see if the archive is not being able to inspect during this 30 seconds period, I can check what the firewall will do with that. So I can allow or block. So if archive is too large for the inspection by my firewall, I will block it. Now the threat emulation is actually inspecting file. It's sandbox analysis, and here we see similar as for antivirus, which deals with known malware. Emulation deals with unknown malware. So we set up what to do with the files. Okay, inspect only files originating from external and DMZ interfaces on the protocols. Which file types I can enable the emulation. These are all supported files for emulation in the cloud or in the sandbox. So I can choose which files I would like to inspect or define to process specific family types. So, or for example, I can say PowerPoints, do not inspect them, just bypass them. Okay. What to do with archives? Same thing. Or if I find some files in the archive, I can see, for example, executable file. I can see, let's block executable files if it's seen in the archive. So these are prohibited files. Okay. Can set up the emulation environment. For example, if I would like to use the specific environment, like, I don't know, I would like to only analyze files in Windows 10. I don't want to analyze files in, let's say, the Windows 7, because I don't want to spend, because more images I'm using for analysis in the cloud or in the local appliances, more time it takes for analysis. So if I know that I do not have any workstations on Windows 7, only Windows 10, for example, then I will just, or with the older version of the Microsoft Office, I will just select Win 10, so it's Windows 10, and my analysis will be quicker. And then the interesting feature, again, against the zero-day infections or the patient zero infections, what to do with the files. For example, while the analysis is still in process, what to do with the files. If I choose the rapid delivery, which is a default, the end user will receive that file even if we are not sure if it's malicious yet. Of course, if we are using the threat extraction blade as well, then we are able to actually extract malicious content from the file before delivering a file to the end user. Or I can choose the maximum prevention, which means that until the sandbox analysis is done, the file will be put on hold, and then it will not be delivered to the end user. Or I can customize, I can choose, for example, for HTTP, just do the rapid delivery, but from the SMTP, delay the attachment from the email until the analysis is done. And that's pretty much it. The threat extraction, of course, what to extract from the files and on which files you want to apply extraction of potentially dangerous content. I can say convert these files to the PDF until the threat emulation analysis is done. So the threat extraction and threat emulation blades are coming hand in hand. So they are using together to protect you from the malware. So threat extraction will convert the files to the PDF until the threat emulation analyzes and detects that the file is not malicious. If the file is not malicious, then the end user will get the original file. Until the threat emulation is not done, while the threat emulation is in progress, the end user will get the PDF version of the file, which is a much safer version of the file. Process all files or specific file types or specific file type files. What to do with the corrupted files? I want to block them. The encrypted files, I would like to block them and deny access to the original encrypted files, because the malware authors are very often sending encrypted files, providing a password in the email to avoid the detection on the network, and then the end user decrypts the file using the delivered password and then gets infected. So I would like to block that behavior. Okay, and that's pretty much it. And then, of course, we need to apply that profile to the specific traffic. Here's the protected scope. You can define object, network object, for the protected scope. For example, I don't know, for the LAN network. Only LAN network is a protected scope. I do not want to protect the internet, for example. And then choose the profile I've just setting up. So it's my threat prevention profile, and if I click publish and install policy, then the firewall will start hunting for malware. Yeah, and one important thing I didn't mention, it considers all the vendors, doesn't matter which vendor it is. All the next generation firewall vendors are now providing a sandbox analysis, not only for files, but also for the URLs you can see in the email bodies or on the web pages, because they are actually trying to protect you from the phishing attacks as well. In the sandbox, they click on the URL from the email, for example, and check to see where this links leads you, or what if it tries to install something automatically on your browser or on your PC, or try to exploit some vulnerability on your browser, for example, to see if the link is indeed malicious or not. So that's it. In the next lesson, we'll see how to configure the threat prevention, anti-malware, which is also called the threat prevention, and on the Palo Alto networks. Hello and welcome to the demo of the Palo Alto Networks anti-malware configuration. In order to configure the anti-malware features on a Palo Alto Networks next generation firewall, go to the security policy and then choose the desired rule, like the one here, and just apply an action. And in the profile settings, choose the desired profile. So just, for example, the antivirus. So you can choose and create new antivirus profile, give it a name. And then you can, of course, configure an exception or different action for a specific viruses or specific malware, or do some exceptions for an application, for specific applications. Like, for example, I don't know, for shared application, I can choose the different action. If it detects malware in this application, I can choose alert instead of maybe drop. But the general way to configure it is just to simply select the action for specific protocol and for specific type of detection. So by default, all detections are set to default. Default means that for protocols such as web on FTP, for these protocols, default action will be dropped. For any of these protocols, if the malware is detected in the traffic carried by any of these protocols, here the action will be dropped. Or in the case of email traffic, the action will be alert, because it's not a best practice to block an email SMTP, specifically traffic, between two email servers if it contains, I don't know, like a bad attachment or potentially malicious attachment. But it's not good practice to just simply drop that traffic by the firewall, because the sender's SMTP server will then not know that if its message has been blocked or its traffic, its connection to the recipient server has been blocked, and it will try continuously to resend that email. And it will try it for a while, let's say for a couple of days maybe. It's depending on the settings on the sender's SMTP server, which will result in a lot of log messages on your firewall about the malware being detected in a specific message. But these logs will be duplicated logs because this is the log that is warning you on the exact same thread. But the thread is repeated continuously because the sender's SMTP server tries to continuously resend the message because there is no response from the recipient server. So the best way is to actually, if you can, but the Palo Alto networks cannot support this. From the firewalls we've shown here, the only checkpoint is able to do so is to actually terminate SMTP connection on the firewall itself. So firewall is being used as an mail exchanger record or SMTP gateway actually. So if the firewall terminates the SMTP connection, then it acts as an SMTP server on a recipient, on the receiver side of an email, and then the firewall will actually send a non-delivery message back to the sender. In this way, the SMTP connection between the sender and the recipient servers will be correctly established and correctly terminated as if the mail has been delivered through, with the only difference that the firewall will actually drop the email with the potential dangerous attachment and send the non-delivery report back to the sender of an email. But from the SMTP server's point of view, the email has been delivered. The SMTP connection has been terminated properly. On the other firewalls which are doing SMTP filtering inline, if they drop the traffic, the SMTP server on the sender side will not know that the email cannot be delivered because, I don't know, of the anti-malware check or whatever. So it will try simply to resend the message because it's a nature of the SMTP server and nature of the TCP protocol that the SMTP as an application is driven on, and that's why it's not a best practice to just drop the traffic for the email protocol, for the SMTP specifically. I mean, you can do the reset client or reset server or reset both. This will result in generating TCP reset messages by the firewall, but acting as an or spoofing the IP address of client or server or both. So the connection will be terminated because when the SMTP application, the sender server usually sees the TCP reset message, it will cease the connection immediately. It will cancel the connection immediately. So, okay, if you must block SMTP traffic on an inline firewall, if it carries some dangerous content, then it's better to do reset with the reset action than with the drop action. Of course, the drawback of the reset action is that the firewall needs to spend the extra CPU time for the extra hardware resources for generating these TCP reset messages. So, yeah, it will have a performance penalty, of course. Okay, this was just a side note, so let's get back to our main topic here, how to configure the antivirus functionality on the Palo Alto firewalls. And here the actions, the different types of detection. So the signature action means that the firewall detected the malware in email traffic, but just by matching a signature or a kind of fingerprint, a binary fingerprint. So we can set the actions, alert or drop, depends on the protocols. Wildfire signature action is actually Palo Alto's sandboxing technology. It's enabled by default. If you have the Wildfire license, it will work for you by default, and you can set what to do if the Wildfire. I will show you next how to configure specifically Wildfire, but here we are just setting up the action. What will Firewall do when it sees traffic content that is already, for example, a file in a traffic that already passed the analysis in the sandbox environment, in the cloud or on the local on-premise Wildfire appliance. And if the Wildfire, that is the sandbox environment, gives a verdict of a file as a malware, it will also record the hash of that file and deliver that hash to the firewall. So when the firewall sees that same hash in the future, it will apply the action specified under the Wildfire signature action column in the antivirus profile. So, for example, in HTTP2, for example, let's say it's going to be a silent drop. Wildfire inline machine learning action is actually a new feature on the Palo Alto network firewalls. We are running here the Pan OS version 10 here on this demo box. The wildfire inline ML action actually means that the firewall will try to apply the machine learning knowledge for real-time detection of some kind of file types such as executables, in order to detect not the specific malware, but the behavior of a malware. So it's actually aimed against the zero-day attacks. Okay, so we just specify the actions, what to do. Let's say I'm happy with this one is here, so I can click OK. So now I have on my security policy rule, which is called LAN to Internet Social Networks, I have these profiles activated already. Antivirus profile, which I created exactly right now. Vulnerability protection, which is an IPS. Anti-spyware, we didn't touch it. URL filtering, it's my URL filtering profile. And the wildfire analysis. The wildfire analysis, we will create it right now. This is the profile for the sandboxing. In here, you simply say what kind of file types you want to send to the sandbox analysis, because, I don't know, maybe due to the privacy reasons or some other security policy, you don't want to send the upload automatically some files, some confident types of files to like a healthcare records or similar automatically to the cloud of a firewall vendor. So here we can specify the name, my wildfire profile, and here I just give it what is the name of the rule. Let's say executable, rule for executables, and applications. Yeah, I can create here, I can click the file types. I can here click some kind of files. Let's say I want to deal with portable executables. These are extremely dangerous because they do not require any installation on the client side. So the potentially infection can occur very simply and quickly. And if I want to do that for specific applications, or I can choose any application, direction I want to analyze it, in which direction, upload, download, or both. Let's say the download. Where I do want to do analysis, public cloud or private cloud. If I have an wildfire appliance locally on premise deployed, then I can use the public cloud. Otherwise, I can use then the private cloud. Otherwise, I can use the public cloud. You can even actually set up the public cloud on which continent you want to use it. It's not only for a convenience and practical side of things, it's just due to the regulation. For example, in the European Union, you need to deal with the GDPR, and then it's wise to, in order to be a GDPR compliant, you need to, if you are using public cloud for wildfire sandbox analysis, you should choose the European Union, the public cloud hosted in the European Union territory, so that you are compliant with the GDPR directive. Okay, I just click OK, and then here I'm in a wildfire analysis profile. So let's see now the anti-spyware. It's not directly anti-malware, but I would like to tell you about one nice option. I mean, it's very easily to configure it. It's just apply what to do if the spyware is seen for any threat. Just give it a name. Spyware policy. What severity of the spyware you want to deal with and on which action. So I can see the drop, or let's say drop. The packet capture, we already have an opportunity to see this option in the antivirus profile or on the IPS profile. Not only on the Palo Alto networks, but on the Cisco, on the checkpoint as well. Packet capture is actually used for if you can tell the firewall if the threat is detected, please record the packet capture that I can later download to analyze it with the packet analyzers such as Wireshark, for example. So it can be useful for further forensic analysis. But of course, it's never selected by default because it will accept for some maybe critical severity attacks. It depends on the firewall vendor, of course. It can take some space on the hard drive, on the firewall storage, so use it wisely. Okay. And another feature I would like to talk to you is the sinkhole, the DNS sinkhole. What is the DNS sinkhole? If you have a corporate network with a lot of organizations, you have actually is that you are using probably an internal DNS server. It's usually Active Directory domain controller, but it can be any kind of box. Its main thing is that it's an internal DNS server. So if you would like to catch, for example, all the firewalls, I'm not talking here about the Palo Alto only. We are in front of the Palo Alto firewall right now, but we are not talking about the Palo Alto. I'm talking about almost every vendor of the next generation firewalls or the IPS and the Trojan prevention systems. So the problem is that all of these devices, like firewalls, are nowadays they are capable of catching malicious DNS requests. These requests are usually command and control attempt to communicate command and control traffic, which infected computers with malware loaded on an infected computer uses to download further instructions what to do. For example, in the case of the ransomware, it might download a private key that it will use for might download the public key that it will use for encrypting your hard drive so that only the matching private key can decrypt it, and the bad guys will deliver it to you, the private key, only after you pay the ransom. So, but the problem is, so when you see some computers on your network that they are using some malicious DNS request, you can be sure for certain that they are infected with something. It can be relatively benign, maybe some Bitcoin miner, but it can be also very dangerous, some kind of ransomware and similar. So sometimes you can be very successful in blocking a malware spread in your network just by simply blocking this command and control DNS traffic. But the main point here is that you want to actually find out which endpoints, which user computers, user workstations are actually generating these malicious DNS requests in order to clean them up or to remove them from the network. And if you are using traditional setup when you have internal DNS server, then your firewall will indicate that your internal DNS server is infected because it generates a lot of malicious DNS requests. But in most cases, it's not about your DNS server being infected, but your DNS server is simply forwarding the DNS requests generated by your clients, by your internal clients, further up to the internet, up to the service provider DNS servers, for example. So the point here about sinkhole feature for the DNS is that you specify some sinkhole IP address. You can give it some address which you want. The only important thing is that this IP address is not used anywhere in your network for some hosts, and that this IP address, it doesn't have to be a public IP address, but it needs to be routable through the firewall. So in order for your clients to reach this IP address, you choose for a single IP address, they must go through the firewall in order to reach this IP address. So you need to have a routing in your internal network that it leads the traffic routes traffic through the firewall for this IP address. So once you set up this, what you will have is that when your firewall detects a malicious DNS request, or of course originating from your internal DNS server, it will simply modify the response from the internet into this sinkhole IP address. So when for example, infected client asks for, command and control mymalware.com IP DNS request, it will get an answer from the firewall, actually, DNS answer from the firewall that this command and control server is hosted on the IP address you configured to be a sinkhole IPv4 address or IPv6. So the infected client will most probably believe that this IP address is really indeed its command and control IP address, and it will try to generate traffic in order to communicate with this command and control server. And then you just need to take a look on the logs on your firewall just to see traffic towards this IP address. So any client generating traffic towards this single IPv4 address is probably, with a high percent of probability, infected because it asked for a malicious DNS request. He's got a reply from the DNS for this IP address, and is actually trying to contact the command and control server, but lucky for you, it's only your IP address in the firewall, so it will end up in the black hole or being dropped by your security policy rule, but it will. So, but you can now detect that you can now be not 100% sure, but like 80% sure that this client is infected. Okay, so this is about sinkhole. It's not only a feature on a Palo Alto, but you can find it on a checkpoint. You can find it on a Cisco. It's there. Just I found a convenient time just to now talk about it, but it applies on all firewalls, not only on the Palo Alto. Okay, so now I have set up my antivirus and just need to commit changes, push the changes to the firewalls so it can start blocking malware on my network. So that's it for about the Palo Alto, and in the next lesson we're going to see what to do in terms of anti-malware on the pfSense open source firewall platform. Let's see what we can do with pfSense in terms of anti-malware protection. Let me get to my pfSense. Okay, very straightforward and easy configuration if you want to basic setup. First, you need to have the Squid proxy server installed on your pfSense, because pfSense firewall, as for any next generation feature we shown here, it requires a third-party product to be installed. And it's actually in this time it's a Squid proxy server, so you need to have to install it. You installed it using the package manager, so go to the available packages and search for Squid, and then you will see the Squid package. After you install it, it needs to appear under the installed packages tab, of course. And we need Squid, not Squid Guard. Squid Guard is an web proxy filter. So we go into the Squid proxy server, then just choose the antivirus tab. So you need to first set up the pfSense to act as a forward proxy server. It's a little bit beyond of scope of this course because we don't have a time for this. It's a separate configuration, but you can easily Google it out for a pfSense, because pfSense has a rich community that has a lot of good advices and a lot of good configuration manuals and videos already. So the pfSense firewall uses Squid for a lot of detection features, except the IPS, for which it uses the snort or the suricata, but Squid is used for web URL filtering, and it's used for, of course, antivirus. The Squid again uses the ClamAV antivirus software or engine, which is bolt on onto the Squid, and Squid is bolt on of this pfSense firewall. So actually, you just configure some things. The most important thing is that you just simply enable antivirus here by enabling this checkbox here. And then you can set up the different options if you want, such as redirect URLs, so it redirects your users if the virus is found in a web page or a file they're trying to download over web page, they're going to be redirected on the URL you specify here. Yeah, of course, Squid is in a web proxy, so with the pfSense you are able to catch malware only on the web traffic. Okay, please keep that in mind. Not in the SMTP, not in the IMAP, not in the regular application traffic, which it's not using browser as a client. On scan type, well, what to scan? All or just web requests or applications even? So like executable scripts or everything. But only of these applications are seen in the web traffic, of course. It just scans the web pages, as it says here, only scripts, images, content of the web pages. Application scans even the files you are trying to download or upload over the web. Let's exclude audio video streams because I don't want to put unnecessary load on my pfSense box. Potentially unwanted applications, it's a clever feature to block some applications like BitTorrent or some similar applications. You need to configure it with the specific files. out of time here for this, unfortunately. But when to download, when to update our database. More often, download the new database update, you will be able to catch more recent malware, of course. Never is definitely never a good option. Nowadays, every hour might be an optimal option because the new malware arises every hour, not regularly every hour, but in every hour you have some new malware. And when your organization is part of some or is under attack by some malware campaign, for new malware campaign, then every minute counts. So you want to have the latest updates for your antivirus as soon as possible. So every hour is okay. You can put it, you can put it on some longer intervals. It depends if, of course, shorter the interval, you need more bandwidth for downloading the antivirus files. You need a more hardware resources. But let's say every hour is optimal nowadays. And you should size your hardware according to this. Database mirror forum where you want to download files, I don't know, United States or wherever you are. Optional servers, you can put them here. Because CloudHub is also an open source, the antivirus engine. So maybe you have your own. Maybe you have a server with your own signatures, or your buddies are developing signatures. You know that they're good, and so you can also include your server of choice for antivirus database update. And unofficial signatures. So there are some other unofficial signatures. By unofficial, it means not developed by ClamApp or its community. It's just an unofficial. So URL house, inter-server, security info. Security info, it's actually a commercial anti-malware database about signatures. So they're claiming they have 4 million signatures. And you can choose the premium, but you need to pay some subscription for it, and then you get some ID to enter here. Then they have let's say it's kind of machine learning training, at least I figured out. So it's like a kind of machine learning training. So your FSense box or engine on your FSense box on a Squid, it will actually be able to detect some unknown malware by just analyzing the behavior of the files. And then just click save, and that's it. You then have basically set up the antivirus on your FSense box. So it's pretty much of it. It's pretty much it. So let's wrap it up. Okay, so it's time to give some key pointers on the anti-malware feature on next generation firewalls. Okay, first thing first. Okay, the anti-malware actually makes your firewall being a malware stopper, so preventing malware basically entering your network. And it's based on two kinds of detection. So one is the signature based. It's most primitive way. It's just trying to detect the malware in the known signatures, using the known signatures for it, but it's good only for a known malware. And the later is the sandbox based. So sandbox means that it actually analyzes the file in the sandbox. It can be locally based or in the cloud. And actually it analyzes the behavior of a file. So if the file turns out to behave inappropriately, or it kind of have a dangerous behavior, the sandboxing functionality actually concludes that the firewall is malicious, that the file is malicious, and then informs the firewall, so that when the firewall sees that file again, it's going to block it. So yeah, it's pretty much it. It's a very useful option. So that's it for the antivirus or anti-malware on a firewalls lesson. And in the next lesson, we're going to talk about very important feature, which is decryption feature, because all of these features we were talking about, like an application identification, the antivirus, the intrusion preventions, even in some form a URL filtering, they cannot be used up to their full potential without encrypting traffic, because more and more traffic is being encrypted. especially on the internet. It's like more than 90% of the traffic on the internet is being encrypted. So actually firewall needs to be able to decrypt traffic to see what's inside in order to apply features such as IPS, anti-malware, the application identification, etc. So stay tuned for the next and very important lesson. Welcome to the decryption lesson of our next generation firewall training series. Decryption is one of the most important features on the next generation firewalls because it unlocks really a true potential of these devices. Since a lot of traffic nowadays is fully encrypted, and without decryption you cannot properly detect attacks by the intrusion prevention system, you cannot properly detect the applications, and also you cannot even properly maybe do some URL filtering. So decryption really increases the security capability of a firewall. Although we do not have any labs here for the decryption, we will dedicate a significant time to the decryption theory because we do not have, unfortunately, enough time for do the labs and the theory. And personally, I think the theory to be understood is more important than how to configure the feature on your particular firewall, because it can be easily found in documentation, because the decryption feature in a firewall is present for like more than a decade. It's not a new feature. So if you look at the agenda, we will go through the prerequisites, what all you need for enabling decryption on a next generation firewall. Then we will jump to how it works page to see how it really functions. And then the most important topic is left for the end is the caveats. So to see what to watch for. So because the decryption is not something that always works smooth on a firewall, because there are numerous challenges and you need to be warned for them. And of course, we will warn you about them here and tell you how you can overcome those challenges. Prerequisites. In order to successfully enable the decryption on your next generation firewall, first thing, you need a digital certificate with the CA capabilities. That is the certificate that is able to sign the certificates for the web servers your end users are trying to visit when they are surfing on the internet. Or because we have two types of decryption. Decryption can be forward decryption. Forward decryption means you are actually decrypting the traffic going from your internal users to the internet, or traffic your users are downloading from the internet. And you will have the reverse proxy. And for the forward decryption, you actually need a certificate with the certificate authority capability. And this is the encryption type. Forward encryption type is the most commonly used decryption type on the firewalls. But also we have a reverse decryption. Reverse decryption is actually a reverse proxy for inspecting and protecting your web servers deployed behind your firewalls. Not only the web servers, but any kind of server that uses digital certificate. So how it works in terms of reverse decryption. For reverse decryption, you need actually a copy of a certificate of your server you want to protect, and also you need a private key for that certificate. So usually it's done by exporting the certificate along with a private key and importing it back into the next generation firewall. So the clients are actually terminating the connections with the next generation firewall, terminating the TLS, transport layer security, and TCP connection with the next generation firewall instead of the real server. And then the next generation firewall decrypts the traffic, inspects the content, and if the content is all right in the terms of the security policy and it's allowed to go back to the downstream to the real server, then the traffic can be encrypted again and sent to the server, or it can be left in clear text, which means unencrypted, and sent to the server. In this way, additionally, we are doing some kind of SSL offloading or decryption and encryption, the crypto offloading of web server. So because the firewall takes all the encryption and decryption load instead of a server. But this form of decryption, that is the reverse decryption policy, is actually rarely used on the firewalls because the most appropriate point in your network to do the reverse TLS decryption or the reverse TLS proxy is actually an application delivery controller or load balancer, because on these, or the web application firewalls, because these devices has much more powerful features for inspecting web traffic, modifying content if needed, and also authenticating clients with the client certificates, because if your web server requires your clients to have a certificate to authenticate with the web server, then the reverse decryption will break that authentication and it will not work. So, but the load balancer or ADC, the application delivery controllers, they have usually a capability to do a client certificate authentication instead of the web servers. So the web application firewalls or the application delivery controllers, such as load balancers, are much better option for reverse TLS proxy than the next generation firewall. So where the next generation firewall excels in terms of decryption is the forward decryption type. So it's used for decrypting traffic from your clients and to your clients when your clients are browsing the internet. So it's protecting your internal clients. So that's why you need digital certificate with the certificate assurance, like a CA capability. But I will explain why in the next slide. We will have a flowchart for SSL decryption operation. Additionally, you need to configure a decryption policy on your firewall to configure what you want to decrypt, actually, because it's not very wise and not very clever to decrypt everything, because it can take a several performance penalty on your firewall, and also it can actually break some applications. We will see that in the last slide. It can also bring some legal issues, etc. But we will talk about these challenges or caveats in the future slides. And also it might be wise to obtain already before you launch a decryption policy onto your production traffic a list of traffic or applications not compatible with decryption. There are some applications that simply do not work with the way how the next generation firewalls do on decryption. So you need to be aware of these applications, or you will face the complaints from your end clients about the applications stopped working, and then you will have to resolve these issues when you launch the decryption on the production traffic. So it might be wise to get this list in a front. But we will talk about why some applications are not compatible with the decryption later. So let's see how decryption works. This is about forward proxy decryption, which means protecting your web clients from internet threats. I mean, you're protecting your internal clients threats from the internet. So let's say we have a client generating an HTTPS request. Fire will inspect that traffic by outbound security policy just to see if this is generally allowed to go to the internet. If yes, then it comes to matching a rule for the decryption. So if it matches the decryption policy, it's going to be decrypted. So the next thing is that firewall, usually you can turn this off or on, but firewall validates the server certificate, which means that firewall can prevent your users accessing websites with invalid certificates, such as expired certificates or certificates not trusted, or the certificates which are not issued to whose subject name is not what your clients are actually aiming for. And if the certificate is all right, then the firewall copies the content of the certificate, such as subject name, subject alternative names, and creates on the fly, in the real time, creates a new certificate. This is why your firewall needs to be equipped with the certificate authority type of certificates, because it needs to be able to create certificates on the fly, in the real time while your clients are accessing a website such as, let's say, gmail.com. The firewall needs to be able immediately to create a certificate for gmail.com that has the gmail.com in its subject, right? So firewall creates a new certificate, presents that certificate to your client. So your client actually completes the TLS handshake, but with the firewall, not with the real server. And at the same time, the firewall initiates a new TLS connection to the real server and creates a TLS connection with the server, with the real server. So actually firewall now, and at this point, firewall maintains two TLS connections. One is with the client, another one is with the server. So after the firewall performs the handshake with the client, TLS handshake with the client, now the firewall is in a possession of a private key or the decryption and encryption keys for the decryption. So now firewall is able to decrypt or read the content the client is sending to the server. And since the firewall also has a connection, TLS connection, an established TLS handshake with the server, firewall is in a possession with the key used for decrypting traffic with the server. So now firewall is able to decrypt, see the traffic the client is sending to the web server and the content what the web server sends to the client. So now firewall sees both directions of traffic in a clear text, and it's able to use its security features such as application identification or intrusion prevention system to detect some malicious behavior and fortunately block that behavior before it can make some harm on your clients. So that's how the decryption works. And yes, to repeat it that once in a short. So client generates the request, firewall captures this request, and if it fits its decryption policy, firewall gets the certificate from the web server, copies that certificate, and create a new certificate with the same content as the web server certificate. Send that certificate to the client, so client thinks that it talks with the real server and continues with the TLS handshake. So the firewall is now part of a TLS handshake with both the server and the client. So the firewall is in a possession of the decryption key, so the firewall can see all the traffic. So it's basically how the man-in-the-middle attack on the TLS works. This is why your firewall needs to have the certificate you use on your firewall for forward decryption needs to be trusted by a client. Otherwise, the client's browser will warn the client that something is wrong with the certificate, and that might be about man-in-the-middle attack. So that's why you want to have a certificate that your clients trust. Okay, this is how it works. And yeah, this because of the fact that the client is actually terminating a TLS and TCP connection with the firewall, and the firewall establishes a new TLS connection with the server. That means the firewall needs to maintain two TCP and two TLS connections at some point. And also it needs to do some decryption. So this is why and not only the decryption, but firewall needs to encrypt traffic back when it's sending to the client or the server. So this can be challenging in terms of performance on your firewall. So that's why you need to talk with your firewall vendor and choose wisely about which model of firewall you want to do, because the decryption has significant performance penalty. Okay, so this is how the decryption works, and it looks simple, but on the next slide we are going to talk about some caveats and some issues that decryption can put on your firewall, on your organization, and on your traffic. Let's see now some caveats about SSL decryption. Well, the first thing first, there are some technical issues and there are legal issues, of course. So the first thing is a certificate pinning. Well, certificate pinning is a feature enabling and preventing the man-in-the-middle attacks on the TLS sessions. And the decryption on a next-generation firewalls is actually a man-in-the-middle attack on the session. So the browsers are armed with the feature that prevents the certificate pinning in a way that they already have the preloaded a list of certificate authorities authorized to sign a particular website. For example, certificate pinning were utilized by some popular websites such as Facebook, LinkedIn, YouTube, Google.com, Gmail, etc. And there's hundreds of sites using the certificate pinning. So when your clients wants to access the websites or applications that are protected by certificate pinning, it will actually break the SSL decryption and break the connection. Because if we go back to our how it works page, we will see that when the client sends the request to, let's say, facebook.com, firewall creates a new certificate. It issues a certificate in real time, which is addressed for the facebook.com. But the public key of this certificate will not be on the certificate pinning list on your client's web browser or the client's application, so the application will refuse to connect to that website. So that's why you need to exempt the sites that are using certificate pinning from your decryption policy. But the good news is that the certificate pinning is actually abandoned by their makers. The Google actually made the certificate pinning and wrote an RFC for standard for this. But time showed us that the certificate pinning brought more pain than use, and that's why in the newer versions of Google Chrome and newer versions of web browsers are actually not using certificate pinning anymore. It's abandoned. So probably it can still bothers you if you are running SSL decryption on your firewall if you have some older clients, but newer clients should not be concerned with certificate pinning and you shouldn't have a problem. But another issue you will face definitely is if web servers your clients are trying to access are requiring a client certificate authentication. Such as some internet banking, for example, because the firewall is able to replicate or impersonate web server certificate, but not the client certificate, because access to the client certificate would require actually to host entire web application front end for a firewall. So that is mostly the reason why next generation firewalls do not support decryption if the client certificate is in the game. Client certificate access can be decrypted by the application delivery controller, such as load balancers, if we are talking about reverse proxy. So because they're actually serving a front end of the web application instead of the real server. But these are different beasts, these are different boxes with different priorities than the firewalls. So yeah, if you have a client certificate, long story short, you will not be able to perform the decryption on that application. And also the performance issues, the decryption significant load on the firewall's hardware. The enterprise firewalls, especially high-end models, are equipped with the cryptographic chips, the crypto processors, so-called crypto accelerators, that are actually taking over encryption and decryption operations from the main CPU. So they are offloading a main CPU for the decryption and encryption. So on these firewalls, you will probably not have a significant performance impact on the throughput level, but the connections per second might still suffer because it requires firewall to actually establish for each TLS connection firewall, we need to have a couple of sessions more than it will have without decryption. First, it needs to terminate the TCP connection with the client, impersonating a server. Then it needs to terminate the TLS connection, then handshake with the client, impersonating the server. and it needs to terminate or establish the TCP connection with the server and to establish the TLS connection with the server as well. And establishing a TLS connections with both the client and server requires also some cryptographic operations for generating keys for decryption or session keys, etc. So it might still have a performance impact despite of the crypto processor. So you have to be careful when you're choosing new firewall if you want to decrypt the traffic. And if we are talking about internet firewall, the perimeter firewall on your internet perimeter, then you must do the SSL decryption generally if you want to use the IPS effectively, because like 99% of traffic is, I guess, encrypted nowadays when we are talking about communication with the internet. So yeah, we need to do the SSL decryption, you need to do the SSL encryption. This is why you need to carefully choose your firewall, properly tested it through the POCs or pilot implementations on your production traffic to see if that model you want to choose really fits your traffic and your further expansion of bandwidth or throughput. And at last, there are legal issues. Because generally, if you enable decryption, then practically since most firewalls are capable of doing traffic capture, packet capture, so you can open that capture recording in Wireshark, for example, you will be able to see the content of the payload of these packets. You will see all the packets normally encrypted. You will be able to see content of these packets in the clear text if you have the decryption. So you're literally capable of reading confidential information flowing in and out of your organization. So you need to get permission from your legal department to do so, and what content they should advise you on what content you should not decrypt. So this content or these applications needs to be put out of your encryption policy or exempted by your decryption policy. This is a content, I don't know, some bank account information, the health information, health patient information if you are working for a healthcare organization, etc. So all these are legal issues and you have to be aware of it. So you shouldn't just enable decryption on your firewall without consulting with your legal department. Okay, so these are some caveats and the solutions for them. So the SSL decryption is not something impossible to do. It's something that you must do if you want to have a full security potential of a next generation firewall. Some key pointers to wrap this lesson up. Okay, the decryption, it really enables your next generation firewall to provide you most security level it is capable of. Without decryption, the IPS is almost useless and the application identification works in a limited way. It can be a forward or reverse type. Forward is when and this is the most common type you want to do on a next generation firewall, is when you are inspecting traffic going out and in of your organization, but this traffic is launched from your clients. And the reverse type is when you want to protect your web servers from the internet clients. And the reverse type of SSL decryption is commonly used by the application delivery controllers or load balancers or web application firewalls. And of course, the decryption has some incompatibility issues, such as the certificate pinning we mentioned, and the client certificates, and performance issues can be significant if you do not consider the proper hardware when you are doing your purchase, and legal issues, of course, if you do not consult with your legal department. So that's it. In the next lesson, we will going to talk about integrating our firewalls with the Microsoft Active Directory or similar user identity service in order to obtain user to IP address mapping. So stay tuned and thank you for watching.